Hello, everyone, and a very good morning to all of you. I welcome all of you to the Single Family Housing Division. My name is Afsha Kansal, and I'm going to be your jury coordinator throughout the day, today and tomorrow. It's also my job to keep us all on time, and I'm going to take it very seriously. So please bear with me wherever I come in interrupting. Our final teams have put in a lot of effort. So they've submitted their project reports about a month ago. And after that, we did have a very eclectic jury stepping in. They took a month to carefully review these reports, and that brings us to our final stage now. So for the single family housing division, we had 3 jury members who expertise in net zero and resilient buildings. It's my honor to be welcoming all 3 of them quickly. So firstly, we have Mr. L. Venkatesh. He's an architect. After very actively designing buildings for more than 25 years, he's now into digital twinning of buildings as a director at Invikara. Hi, Venkat. Second, we have Ms. Shaili Goswami. She leads the building science team at Saint Gobain, India. She has over 7 years of experience and is involved in simulations and measurement-based assessment in buildings. Hi, Shaili.
Hi
And thirdly, we
everyone.
have, yeah, hi. Thirdly, we have Ms. Saswati Chetia. She is an associate director at Green Tech Knowledge Solutions. An architect and an environmental planner by training, she has about 15 years of work experience. She was also a part of the core team that developed the Econivas Samhita 2018 alongside the Bureau of Energy Efficiency. So our jury members have put in over 2 weeks' time to review the submissions which were made by all the teams, and we have 6 teams in totality under our division for today. They looked at all the work in detail and have already assessed the entries against the 10 defined contests. Students, your presentations today is going to help them hear your narrative. They will assess your presentation and your mastery over your solution through a quick Q&A session at the end. Based upon what they hear today, they will definitely have an option to be revising your scores. So please, I wish all of you the best so that you can all adhere to whatever set conditions we have for today. So very quickly, I'm going to get down to the first presentation. So our first presentation today is by Team IM. Hi, team. They worked on the project Green Abode, located in Kumaragiri, foothills of Chikmagalur. Their project partner is Terra Consulting, and that is represented by Mr. M.N. Chandrasekhar. So I'm going to do a very quick AV check with all of you one by one. Please unmute yourself and just say hello. So I start with Ruksar. Hi, Ruksar.
Hi, good morning.
Good morning. Hi, Param.
Hi.
Hi, Hardita.
Hi.
And hi, Kritika.
Hello.
Thank you. I request the team to please share their presentation now so that we can add it to stream and begin. I'm not able to view your presentations on the back end.
Yes, ma'am. Just a second.
So anyhow, I'll just very quickly give the set of instructions that all of you need to follow. In the meanwhile, you can get to your presentation. So all of you are going to have 25 minutes to be presenting in front of the jury today. At 20 minutes, what I'm going to do is I'm going to give you a very small reminder. This has to let you know that you have just 5 minutes left to wrap up. But at the end of 25 minutes, this bell is going to get a little more aggressive, and I'm going to jump on the screen and stop you in case you haven't stopped at your own pace. So please bear with me if that happens. And immediately we'll have the jury step in and start the Q&A round. Okay. So I think the presentation is set. Team, are you ready?
Yes.
Okay, perfect. The stage is all yours.
Good morning to the respected jury, all the participants, and the audience. Today, we, Team IAM, present to you Green Adobe. So, I am Ruxar, and I will be presenting today alongside Hardita, Param, and Kritika. Can we move on to the next slide? So, as a team of architects and engineers, we have been working for months under the mentorship of excellent faculty to not just attain an efficient and sustainable solution, but to also make the project fulfill the dreams of our client. Next slide. So, Adobe is for Dr. M. N. Chandrasekhar from Terra Consulting. So, the client had very particular interests and demands for the project. They wanted the project to be acclimatized to the climate of Chikmagaluru, Karnataka. They wanted it to be true to the identity of Chikmagaluru, and also they wanted the structure to connect to the outdoors as well. So the site was situated in the Kumargiri foothills of Chikmagaluru, Karnataka, and it was surrounded by luscious green tea estates on all the sides. So out of the 8 acres of land that was available to us to choose from, we had to select 468 square meters. So we selected a site within the 8 acres that is abutted by roads on two sides, has contours, and has access to views such as a water body and green trees all around. So that was why we had selected this particular plot. Now moving on to the next slide. So our main goal was to make sure that the design is able to face the climatic challenges and the challenges that the site offers to us, having a very steep contour. So having been to the site ourselves, Chikmagaluru experiences a huge amount of rainfall in the monsoons, and the winters also tend to get very cold. So we wanted to make sure that the comfort levels are balanced throughout the year, and the client, like they had demanded, experience outdoors while they were indoors as well. The relationship was very clearly defined. So we've tried to incorporate all the 10 different contests and tried to perform in all 10 of them, make sure that our project is true to all of them. So to start with, next slide, the basic performance specification as to what we have done with respect to the climate. So firstly, when I mentioned about rainfall, Chikmagaluru experiences about 1000 and 1200 millimeter of rainfall every year, and the humidity levels during the monsoons is also very high, and the winters also tend to get very cold. So our main goal was to make sure that the humidity indoors does not exceed beyond the comfort range, and in winters we allow maximum amount of heat gain, and the summers are also pleasant. Now the entire site is covered with silver oak trees, being a coffee plantation. So we did not have much challenge with respect to summers, because the structure would not have received much rainfall. Our one challenge was to make sure that enough sunlight reaches the solar panels to make use of that energy. So as for the roofing, what we've done is we've used a standard 30-degree pitched roof with vapor coming out of the roof, and the entire site is covered with
I think there's a technical glitch at Ruxar's end. Can someone else please take over and continue?
Yes, ma'am. So, like she mentioned, we really didn't face a lot of challenge when it comes to summer temperatures. And moving on with the performance specification, so we have tried to use cavity walls. Hello, am I audible?
Yeah, you're audible. Kiran.
Yeah, so we have tried to use maximum of cavity walls and a pitched roof which requires 50 insulation to protect from cold, and in addition requires a vapor control layer. And in the south and west walls are cavity walls, that is 1 or 2 brick thick with 13 plaster, and no insulation to avoid too much head gain during the summer. The north and east walls are solid brick walls, that is 343 brick with dense plaster to allow heat gain during the winters. Coming to EPI, that's Energy Performance Index. So the Griha specification for EPI for residential building is 70 kilowatts per meter square per year. So the goal was to achieve less than or equal to 50% of reduction in the EPI. Thus, the final achieved EPI after calculation is 60 kilowatts per hour per meter square per year. Also, renewable energy sources like solar PV system and biogas was also considered and implemented.
For the orientation of the house, for receiving the highest sunlight inside the building, we have oriented the building in south and west direction. For the spaces which are mostly used, they are facing towards south, and the spaces like kitchen and dining which are not used throughout the day and only certain times of the day, they are placed towards the east. The library is towards the west with huge window to capture the heat from sun, creating greenhouse effect and warming the space. In this slide, we see that there are the roof is highlighted in red color, indicating that the roof is receiving the highest amount of sunlight on the house, and yellow color representing the minimum amount of sunlight entering through the large windows in the house. Next slide. For the shading of the house, we have provided horizontal shading over the balconies and terraces with sloped roof to avoid waterlogging, because we receive a highest amount of rainfall in the site. And as the site is located in the coffee estate, we find silver oak trees to protect coffee, as well as providing a lot of shading to the house. So we do not need to provide vertical shading over the skin of the building.
Talking about water performance, the standard norm for domestic usage was is 135 LPCD as per Central Public Health and Environment Engineering Organization, and then thus the water consumption in the project was brought down to 80 LPCD from 135 LPCD through water saving fixtures. Rainwater harvesting is an additional source of renewable energy and serves and the reuse of treated grey water for flushing and irrigation also minimizes the water consumption from the grid. And like I explained, uh, rainfall is something that is very prominent in Chikmagaluru and certainly an additional resource to us. Thus, we try to maximize use of rainfall rainwater harvesting system that in return can also recharge the groundwater, and also a little bit of grey water is reused and recycled for irrigation of landscape and for flushing of toilets, whereas the rest of black water is sent to STP. And we could at the end of we reached a water consumption level of 1,95,416, which was pretty less than the water source available to us, that is 5,24,500 502. So the net zero water building in the total water consumption should be equal or less than the water source. So according to the calculation, we've achieved the net zero criteria. And also talking about water treatment, a little bit of gray water can be reused and can be used for flushing and irrigation. So in this particular diagram, the closed loop design aims to achieve the target of zero water discharge by allowing water produced on the site to be returned to the site, and grey water generated is filtered at 75% efficiency and treated and treatment plant before being sent to non-potable UGT, that's underground tank, and reused for other activities.
As we know, this the site is very sloping, so providing proper vegetation holds the soil in the place and avoids soil erosion. And for the earthquake, as we recently we have seen that there was an earthquake in Chikmagalur, so we have to take care about earthquake too. So to prevent earthquake, we have used flexible foundation for the base, where it is made of rubber, steel, and lead. The base moves during the earthquake, and isolators vibrate while the structure itself remains steady. On-site energy production. Prime on-site energy generation is also needed in remote locations with no utility power available, or where the available utility power feeds over the supporting grid. And other large power demanding construction projects sometimes face this challenge. For the envelope selection, we have narrowed down few local building materials and checked through the material cost, thermal mass, and thermal conductivity, and we came up to the final material selection as stabilized earth blocks, as it was the most suitable one for the soil available in the site, which is lime, which was the prominent material for the site. And for the construction time, foundation would have taken much of the time for construction, and which is around 6 to 7 weeks. And then services would take again 5 to 6 weeks for for the construction, and the work would be finished by 3 weeks at the end. For passive strategies, we have included courtyard in the center of the building to let daylight and illuminates all the spaces, giving the sense of volume to the building. And cross ventilation is most important to the warm and humid climate regions. And windows are provided to ventilate most of the spaces in the building. We have used shading for the external overhangs, and outlets for sieve and vent out here. And for active strategies, we have used artificial lighting in the building to provide light in the night time. The orientation of the building is in such a way that it receives much of the sunlight during the year. The goal is to maximize the amount of sun to heat space, resulting in using less energy to mechanically heat. For the health and well-being, we have made sure that clients' well-being is much taken care of, and to control the humidity and temperature in the building by using prominent materials in the building. In indoor air quality and ventilation is used well. Thermal comfort of temperature and humidity is made sure it's perfect. Visual connectivity of daylight and artificial lighting is used. Safety and security of the client is made sure in the building. Interior layout active, and it includes design and look and feel. We have made sure that connectivity to nature is prominent in the building. Location and access to amenities and outdoor spaces is made sure. Building orientation is in north and northwest and southeast to improve ventilation in the warmer weather and improve thermal comfort and humidity in the building. As we know, Chikmagalur's temperature is colder, and during the winters it drops to a very low temperature. We have oriented and open spaces in the west and south, so that much of the sunlight enters into the building and warms the house. For the climate modification strategies, we have used a passive building model, so that we use a minimum of non-renewable resources, and by using microclimate, macroclimate topography, and building form and fabric, we have resulted in minimum non-renewable energy.
Yeah, so coming to the floor plans, the building is designed keeping the contours in mind due to the level difference of 3 meters from southwest to northeast. We got an advantage of considering the basement. The floor plans are designed with respect to Vastu as it was one of our clients' demand. Vernacular style of architecture with the present contemporary style has been attempted in the design, since the client wanted the design to be something unusual, keeping the local architecture in the mind. Next slide. Also, the client's major concern with respect to the design was to blend the units with the environment of the coffee estate. Hence, we have designed the floor plans with respect to that. Large bay windows are provided to ensure proper daylighting, heating of the interior spaces during winters, and also for proper cross ventilation, and especially for the views. And also, multiple balconies have been provided to satisfy the client's requirement. Next slide. Yeah, this is again the floor plan of the first floor and the roof plan. Next slide. This slide shows the site elevations from different views. Yeah, the site section over here shows the different level of the buildings. Next slide. In the construction details, we have shown the foundation plan, the foundation detail, and the beam layout plan, which is a typical beam layout plan for all the floors. Next. These are just the construction details. This is the terrace plan, which shows the slope of the water and leading towards the drainage pipe, and the water again collecting towards in the storage tank for the rainwater harvesting. This section over here shows the kind of foundation we have used, that is the RCC foundation, and the column width that is 300 into 300 which we have used. The external wall is of again 300 Next block. These are again the basic construction details of the. Yeah, so in this slide, we speak about the equipment selection and operational schedule. The main goal here was to choose appliances that were energy efficient, low maintenance, and had a long lifespan. Of India Bureau of Energy Efficiency star labeling software. And EPI was reduced by 14 kilowatts per year to 8.5 kilowatts per year by using the equipments which are mentioned in the right, the flow chart shown towards the right. The chart over there shows the detailed information about the equipments, the company model and power, and the cost of the equipments we have used. Next slide.
Talking about the scalability and market potential. So the project is situated in extreme conditions with a very steep terrain and extreme rainfalls and lack of sunlight. So with minor changes, the project can be suited to any condition. So using technologies that require less water, and then maximizing the usage of solar power when there's very less sunlight available to us, this project really highlights its ability to make the entire project very sustainable. So different strategies have been utilized that we just mentioned, making it very profitable. Also, in terms of the material usage, we've used materials that are not only low cost but also true to the site where the project is situated, by the usage of local materials. So low cost materials and effective selection of material also makes the site very project very profitable and very scalable, because it can be suited to every housing need. Thank you.
Thank you, team. Well, you've definitely delivered within the given time frame, and that's been excellent. The presentation was also very good. So I think it's time for us to bring our jury members up now and hand over the stage to them. So, hi, jury. I'm going to go one by one, and you can please start putting your questions and comments and reviews forward. So, Venkatesh, I'm going to start with you.
Great. Good morning, team. I am, and I hope you can all hear me clearly. And great job. Congratulations. It requires a lot of persistence and energy and interest to come this far. And I hope that this is only a milestone and you all go ahead uh, and also be able to build this successfully. You've done a really good job. I appreciate it. And I'm an architect, so I mean, you guys have done a really good job. And the only thing that I will call a little disappointment for myself is I would have thought that you guys should have been a little more daring in your design, right? I mean, your design is good, but I would just kind of have like to see little flourishes here and there, which kind of the important thing about a building of this nature, right, is that it's got to tick all the right boxes, but at the same time you got to have a little extra that will actually make people look at it and say, wow, that's what I want, and come back to you guys with a real new project which you can build. A few things. You talk a lot about innovative materials, etc. There's a talk about hempcrete in your presentation, but you really did not touch about it when you spoke here, because that is really something different, right? I mean, Adobe is something that you can do, and to me, Adobe is not really scalable. Maybe in Chikmagalur you could do it, but there are a lot of places where you won't be able to do that also. So perhaps one of the things that you should take back as a lesson learned is that. In terms of materiality, that is something that you can look at better. Forms, you could be a little more daring, and resilience, right? And this again, these are just life lessons, right? I'm not being critical. I'm just telling you that you talk a lot about resilience with earthquake and the foundation design, which is suitable for earthquakes. But when you look at your drawings, that doesn't really carry forth in that drawing. Your foundation drawings look really conventional. So if there's earthquake in Chikmagalur, then I'm going to step out of your building for a while and then walk back inside, right, till the building stops shaking. Um, Another thing is you talk a lot about your roof detailing and wall detailing, but when you show your architectural plans, I'm quite sure that they don't really mix. So please make sure that when you talk about a detail and you give an enlarged wall section, at least that thickness of wall and that many layers for lines reflect in your presentation, because these are small things, but and I'm sure your teachers would have drilled it into you in school. God is in the detail, and that's something that you really need to pay a lot of attention to. Um, I know you're architects, and I'm an architect too, and costing is not something that I enjoy. But again, that is something that you could have done better, because an MEP costing was something I thought was a little weak with you people, which is fine. I mean, even today, air conditioning and electricity gives me the jitters, so I don't find nothing wrong with it. You guys are normal, but that's something that you need to strengthen and go forward. That's about it. Just the last one. Your water balance could have been a little stronger, because Chikmagalur is typically water positive, especially in these coffee estates, and you have a lot of gray water. And I really don't know how you are using it effectively. So that's one thing that I wish you could have done a little more research into, right? Probably with so much land around, you don't even need an STP. You could have done root zone or something else to treat the grey water and use it. But apart from that, good job, congratulations, and wish you all the best as you guys go forward.
Thank you, sir.
Thank you so much, Venkatesh. Shelly, I'm going to go to you next.
Okay. So I too would like to applaud you guys. I think you have done a good job. You have also tried to integrate the net zero energy as well as water approach in the building, along with keeping in mind the features like vernacular materials or design features, or even you have tried to accommodate the comfort requirement that the people or the end client had requested for. So I think that way you have tried to integrate it in a good way. So I mean, good job. In terms of comments, I was just trying to think that you have tried to kind of done, you have tried to do the analysis. Like I could see the solar radiation analysis, but I don't know exactly how you have tried to kind of optimize the design per se, because it seemed like that the design is being made and then you're trying to look at the radiation. Whereas once you're evolving the design, there has to be some sort of process that I felt was probably could have been good if you would have also added it. And before the optimization, the first step should be also to analyze the climate accurately. So one of the things that I felt was the external temperature ranges. It's just written that it's going to be from 11 to 25 during the winter times, and you would want to increase the heat transmittance because of that. So probably these are the two things that you have to justify. Why is it that you're trying to kind of increase the heat transmittance in your space? And why do you think that only the temperature ranges are from 11 to 25 in the winters? So you also need to look at the temperature ranges maybe in the summer or even in the monsoon time, because the space need to be understood in terms of its functionality throughout the year. So I think that was one thing that was missing. And also one small point, I think the climate consultant outputs that you have shown are for the weather of Mangalore. So I think Mangalore and Chikmagalur, your site is very different. So probably the temperature ranges that you're looking at, you can just do a quick check with that. But I think that's one of the most critical point. You start with looking at the climate and understanding it very precisely. Because of that, your building optimization, design, and even material selection depends on. Then the second point was about selecting wall materials. So I could see that you have selected 350 thick brick walls, and you've also taken single glazed unit on east and north side to facilitate the heat gains. Now, again, all these questions are like coming back to what were the steps that actually led to this kind of material selection were kind of not clear. So, I mean, it would have been good if you could have actually taken a step of, okay, why am I selecting this insulation and why this material and how it will actually impact the overall heat gains or say the overall temperature ranges inside the spaces. So these were the points. And then moving on to the selection of wood and hempcrete. Just to add on to Venkat's point, I think if you are speaking of scalability, this would also result in a lot of moisture-related problems, because of the nature of this material. You also have to look at the practical implementations that might happen once you are selecting these kind of materials. Uh, but apart from that, I think it was good. So good job and congratulations.
Thank you so much, Shelley. I'm going to hand it over to Saswati now.
Hi. So great work, guys. And because I know over 9 months you've been working on the same design, and there are so many multiple technical things that apart from the design aspect that you anyway work in school. So it's quite challenging to even understand some of the concepts and even quantify some of the concepts. And that's something that I'm going to come to right now, because you have given a lot of qualitative statements, and going forward you will need to quantify them even in terms of how you're looking at the climate itself, because at times you have said that it's very low, like you said the temperatures are very low, something like that. But is 11 degrees Celsius very low? There'll be people who will differ with that, because once you have the quantity and the quality aspect of it don't merge properly well, then you might like kind of over design some things, under design certain other things in terms of your this thing. So it's very important that you understand what it really means, what is very low, what is this thing in terms of quantities. I have two small questions to you, maybe just as a clarification, because I mean both Venkat and Shelley have also spoken about the materials as such. I am still like, what material are you actually proposing for the walls? Is it brick cavity wall? Is it SSCB or SSCB cavity wall? If you're talking about hempcrete, where are you using it? I mean, can anybody just unmute themselves and tell me finally what is the wall that you're using?
Ma'am, we were
type of.
using brick mainly and
Okay.
blocks, but when we mentioned hempcrete in the final slide, what we mentioned was hempcrete is gaining is becoming very popular by the day because of how sustainable it is. So when we're scaling our project to different aspects is when we can use hempcrete as a material instead of what
Yeah.
we've used now.
So when you're presenting, these things need to be clear because it comes out as confusing at times. Okay. So there were, even in your report, there were multiple things, so we were not clear in terms of what is it that you're actually using. I won't get into whether hempcrete becomes scalable, not scalable, that kind of thing. Second question, maybe I missed it for some reason. What is are you generating energy on your site, and how are you generating on your site in the presentation? I mean, I did not see a mention of it. I mean, are you using any renewables? Because we are talking about net zero buildings, right? So uh, you did talk about, like, okay, your EPIs and things like that, but when you're talking about net zero, you also have to generate that energy and use it. So are you using renewables at all? That's a question. So if you can, um,
Yes, ma'am. Actually, we are with regards to I mean, with regards, we are using solar panels to generate electricity that's on the rooftop. And the other thing was the biogas plant, because again, we are in the site of Chikmagaluru and there's coffee estate around it. Also, there's a lot of uh, cattle and lot of livestock around as well, so that also adds on, so that also can be used in biogas. And the other one is being water positive, that's the rainwater harvesting system. So these three were the main renewable source of
okay.
energy that we thought.
All right, thanks. So going forward, I think you will need to acquaint yourself, get more comfortable with these calculations. Some of the calculations are pretty straightforward. It's easy to do a quick thumb rule type of calculations on this, because when you're talking about net zero energy or net zero water, as architects also you need to get more comfortable with calculations. So that's all from my side.
So thank you very much to the team, and a very big thank you to the jury as well. I think you definitely deserve a big round of applause, team. So be very happy and go and relax now.
Yeah.
Yeah, best wishes. Great job,
Thank
team.
you.
All
Very
the
nice.
best. All the
All the
best.
Thank
best.
you, Judy. Thank you.
Thank you. So we are going to take 5 minutes. This is for the jury before we move on to the next team. So we'll just very quickly get all their back end sorted.
Got it.
Yeah, thank you. I'll get back to you guys soon.
Yeah. Thanks.
Thank you for waiting and welcome back, everyone. Our next presentation is from Team Arnima. So they've worked on the Nilaya housing in Thiksay, the Leh district. Their project partner is Asim Foundation, and that was represented by Mr. Sarang Gosavi and architect Neha Gugari. So I'm going to do a very quick AV check with all of you. I'm going to take your name one by one. Please unmute yourself and say hi. So I'll start with Yash. Hi, Yash.
Hello, ma'am. Good morning.
Hi, Omkar.
Hello, ma'am.
Yeah. Hi, Tane.
Hello, ma'am.
And hi, Rutuja.
Hello, ma'am.
Yeah, perfect. I'm going to request you to please share your screen on the presentation mode on the back end so that I can add it here. In the meanwhile, a few very quick instructions. Like you've
Yes,
all been told, you get 25 minutes to make your presentation. At 20 minutes, you are going to hear a sort of mellow voice from me. So that's going to be, so this should give you a warning that you are at your 20th minute and you have only 5 minutes left to wrap up. However, if we do end up reaching the 25th minute, I'm going to come on screen and interrupt and stop you guys there and then. After the presentation, we will be inviting our jury on the platform, and they are going to hold a Q&A round for 15 minutes where you can seek clarity and they can seek clarity on whatever things have been presented. So thank you, team. All the best, and the stage is all yours.
thank you, ma'am. Ma'am, should we start?
Yes,
Hello?
yes, you can start.
Okay.
Yeah, yeah.
A house is a mega structure which belongs to the living, but a home is a structure which forms the identity of the space around. We, Team Arnima, take up this vision of preserving the identity by proposing an ideal home. Leah has its own fascinating vernacular architecture, but the recent change in government norms and development has ignited the concretization of the buildings, hence making a shift in the construction market of Leh. This triggered our minds to propose Nilaya Housing, a net zero solution that blends with the traditional vernacular architecture and culture of Leh. For this, we approached Asim Foundation, our project partner, which is a non-governmental organization that supports the development and livelihood of people in the border states of India, who gave us a project with a vision to develop an affordable housing community for the local villagers in Thiksay village of Leh. Leh being a cold desert, it receives extreme cold winters from November to February and hot summers from March to June, which makes it hard for people to live in. Further detailed background research was done to understand the culture, occupation, and architecture of Leh, where we understood that the local villagers in Leh live a sustainable lifestyle with farming and cattle rearing as main occupation. There is also symbiotic living of humans and animals, which is the traditional practice of Leh. But due to these extreme temperatures and topography of Leh, they also face severe issues like thermal comfort, water issues, electricity problems, and resilience. To tackle these issues, we set some goals and accordingly strategies were laid down. They are as follows: promote traditional vernacular architecture, overcoming the electricity issues, mitigating the water demand, effectively manage the waste and use it on site, to construct a resilient structure, to propose innovative solutions, to maintain the thermal comfort and promote health and well-being, to make the structure scalable, hence increasing the market demand, to promote cultural activities, and to design a low-cost net zero structure. The site has strengths such as topography, splendid vernacular context, opportunities such as great housing demand, weakness such as meager infrastructure development with extreme climatic conditions, and threats due to seismic zone. The site is located in Thiksay village, which is 15 kilometers away from Leh town. The context is the Tikse monastery on small hill to the immediate east of the site. The Indus River flows to the south, making land loose and fertile. After understanding the context, we did the site analysis where the sun path is from east to west via south and predominant winds are from west. Considering these conditions, the individual modules were tilted and made perpendicular in north-south direction. The site is contoured with the site area of 4480 square meters with 448 square meter per module. The slope of the contour site was used in generating material on site. It is also used to create levels in the spaces, which indeed help us in earth bombing. The spaces are arranged for a single module to form massing of the whole building. The building entrance is designed on the east side with a buffer space. The highlighted part is the whole building, which forms the circulation of the spaces. Dry toilets are provided on the southern side, helps us to eliminate the foul smell from the dry toilet. The major habitable spaces are arranged on the southern side with larger openings and provision of the sun space to the master bedroom, which traps in maximum heat. And the northern side include the kitchen and the bedroom. Prayer hall, an important space, has been positioned on the upper floors. The module being repeated, which forms a community where site level strategies are implemented, such as overhead water tank, shaded sitting spaces with landscaping of native vegetation is done to promote interaction, small sunken amphitheater for celebration of festivals at community level. The section shows like the key plan where the section shows the differences created in the spaces that helps to inculcate the symbiotic relationships of human and animals and the usage of dry toilets. Some views showing the interiors of living room and kitchen reflecting the traditional vernacular architecture. The intricate wooden members in the elevations explains the blend of traditional architecture with modern ways. The views on the right part gives the essence of layers vernacular architecture. Further, the schematic section explains the services part where the process of energy generation with the help of solar panels, then the process of radiant heating system, lastly the generation of biogas which will be supplied to the radiant heating system and bukhari, a traditional heating element which is used for cooking and heating the spaces in the kitchen. Coming to the details section indicates the external wall showing the details of foundation, plinth, and superstructure wall to help resist the earthquake loads. The detail section of the sun space indicates the alignment of glass in a tilted manner, which will be perpendicular to the direction of the sun radiation, ensuring maximum heat gain into the space. As the structure is a pier beam system, then it is fixed with the help of the joineries between the stone pier and wooden beam, which is fixed with the lime mortar. The detail on the right part shows the flooring layers in the living room and kitchen. The flooring in the living room is supported by wooden members and the flooring in the kitchen rests on the earth layer beneath. Maintaining thermal comfort in the indoors is the most important part to overcome the extreme climates in Leh. This was achieved by the utilization of passive solar strategies such as earth warming, where the contoured land helps us to heat gain at night when the exterior temperature falls to minus degrees. Provision of cattle shed below ground helps in the symbiotic living and heat gain through radiation from the animals. Provision of sun spaces helps in trapping the heat into the space during the daytime and at night is released to the exterior spaces. As most of the livable spaces are arranged on the southern side, trombe wall helps to draw in the heat during extreme temperatures. The inside of the trombe wall consists of a dark colored layer which helps to absorb maximum radiation. The roofs and floors are constructed in a series of layers that helps to retain the heat inside the space with negligible heat loss to the external environment. Further, the design is being simulated for PMV index graph, which indicates the indoor space that remains warmer and thus maintains the thermal comfort. The daylight simulation states that the optimum daylight enters the space, which can be easily travel up to 7 meters. We also tried to innovate the traditional heating system known as Bukhari, which helps heating the interior and cooking. The main problem with this technique was burning of wood and dried cow, which increases and dried cow dung, which increases the carbon emission and smoke affecting the health and environment. So we introduced a module wherein we tried to lit up the Bukhari with the help of biogas, and to help this heat to last for a longer period of time. We also used biogas also use biogas efficiently. We made use of mud bricks and sand. A metal pipe is connected to the Bukhari that will help to heat up the living room with the help of radiation. Another active strategy we inculcated was the radiant heating system, for which biogas is used as a fuel to heat the water. The water heated will be transferred to the pipes laid below the floor. This will radiate the heat to the upper environment. Losing all the heat, the water will again be pumped to the heater, where the water again gets heated. This helps us maintaining the internal thermal temperature of the habitable spaces, and the cycle goes on. To enhance the building technology, we tried molding the mud excavated from the site into hollow CACB blocks. This hollow portion will be used to insert the wooden reinforcement in it, which will help these layers to be in position withstanding the earthquake loads. A cavity wall will be built by the same blocks and filling the cavity by reusing the waste wool produced from the pashmina textile industry, which will help better thermal insulation.
Elaborating about the energy performance, the graph indicates the considered benchmark EPI for the cold climates from Griha as 100 kWh per meter square per year. For the pre-design stage, we achieved EPI of 36.6 kWh per meter square per year, but to achieve thermal comfort in extreme weather conditions, usage of only passive solar strategies won't help. Hence, we inculcated their traditional heating system known as Bukhari and hydronic radiant floor heating system. This eventually increased our EPI up to 71.06 kWh per meter square per year, and the final design case EPI we obtained is 66.08 kWh per meter square per year, which is 34% reduction in energy demand as compared with the base case. Further, we have the design optimization for the base case and design case and the VU values, which helped us to achieve the EPI of 66.008 kWh per meter square per year. For the energy generation, we use solar panels to generate 15% of the energy, of which during winters and monsoons there would be 100% usage of the produced energy, with no extra energy would be generated for the grid. During the extreme weather conditions in winters of maximum 10 to 15 days, there will be no energy generation. Hence, we have the provision of batteries that would have the power backup for the 15 days. But during the summers, there will be 22.18% extra energy generated, which will be stored in the battery, and the remaining will be further donated to the grid using net metering. For the other 85% energy generation, biogas is used. During normal days, when the generation is 100%, 51.4% energy is used, out of which 4.2% of energy is used for Bukhari. 31.25% of energy will be used for cooking at night. For the radiant heating, when the temperature falls during the normal days, 16% of the biogas will be used, and remaining about 48.6% will be given in the surrounding communities. In the extreme climatic conditions, the generation and consumption is 100%, out of which Bukhari heating will require 8.3% of energy. For cooking purpose, 62.5% energy is used, and for radiant heating, about 29.2% of energy will be used for heating water for the thermal comfort. In summers, ample amount of energy is generated, which is stored in the batteries and also given to the grid. The parabolic solar disk will help cooking during the daytime. The bar graph indicates the energy generation and consumption and supply to the grid in all seasons. With the availability of the biogas on site, in summers, ample energy generated from the biogas enables extra energy to donate to the nearby communities. The energy chart indicates the generation and consumption of biogas in normal days and extreme conditions. By studying various types of electrical appliances and fixtures, we found these detailed ones to suit the best, which lowers the energy demand. The daylight graph indicates the adequate amount of lit areas as compared with the requirements. Comparing the base case and design case, we can see the evolution of design and the strategies involved to increase the daylight. The average temperature graphs indicates the extreme outdoor temperature and the achieved comfortable indoor temperature. Also, for the solar panel, the volt solar panel we found to be the most affordable and effective option to cater the energy need. Water management. The main approach towards net zero water is to preserve the quantity and quality of natural water by utilizing potential alternatives of water sources. As per Ministry of Housing, 135 liter per capita per day has been suggested as the benchmark for the water supply. By using dry toilets and aerators for the fixtures, LPCD has been reduced to 75 liters. Annual water consumption is 180 kiloliter, out of which 126 is grey water and 126 kiloliter is grey water and 26 kiloliter is black water. Water is made available from the Tikse monastery. Water is stored in the OST of 6 kiloliter capacity, which is twice the daily consumption and situated at the community level. 40 kiloliter water is transferred to the solar water heater. 17% of water consumption is reduced by using dry toilets, while 30% is reduced by fixing the aerators to the fixtures. 85% of water gets recycled, which is used for different purposes like irrigation, radiant heating, biogas, and for domestic purposes. Because of the less rainfall in Leh, rainwater harvesting is not feasible option, and water consumption is bifurcated into domestic purpose, irrigation, and the biogas. The site layout shows the water supply and drainage layout for the community of 8 modules, which are planned considering the existing topography and hence the gravitational force. Grey water is circulated through various processes of filtration like settling, root zone system, also known as reed bed system, chlorination, and then stored in the tank of 4 kiloliter capacity, which is then pumped again in the OST. Further, the water required for the drinking and cooking purposes is filtered in RO plant. The greenhouse is built over the root zone to maintain the temperature for sustaining species like adu and kardar. The pipes are installed 6 to 7 feet deep in the soil to get thermal insulation through the soil and preventing it from freezing. To mitigate the water deficit problems, we propose the ice stupa of 7.5 meter high in Tikse village in higher altitude area where the water from the mountains can be easily collected with the help of gravity. The formed ice stupa can generate 2 to 2.5 lakhs liters of water, which can be used by 2200 people for 4 months. The nature of water is to get balanced in any shape it is contained in. This basic phenomenon of water is applied for the generation of ice stupas. 45 kiloliter of water from the ice stupa will be used for our site and the remaining will be shared with the other communities. Waste management. Waste management on site is divided into 2 parts, animal waste and human waste. The animal waste is used for generating energy in the form of methane in biogas. The slurry is converted into manure, which can be then used for agriculture. Human waste generated in dry toilets stored in the pit where continuous layers of sawdust and dry mud is added. This waste is removed and pit is cleaned every 6 months. Then it is allowed to form a manure which is then utilized in agricultural fields. We also have solved the foul smell issue by providing an air outlet duct with drum wall on outer side which would heat up the pit and warm air will rise up and move out. Resilience. Leh being a highly earthquake prone region, it is placed under seismic zone 4. So to make it earthquake resilient structure, we have used horizontal lintel bands and vertical wooden bands, which ties the structure in both directions. Lightweight materials are used to reduce the dead loads. The structure is supported by a stone pier and a wooden beam, forming a grid for better load transfer. This is held strong by the stepped foundation, which will be helping to resist the dynamic movement of the structure during the earthquake. Moreover, the structure is planned proportionately, making it more stable. Water issues are tackled by providing solutions like recycling 85% of grey water by reed bed system and proposal of ice stupa concept at a regional level to cater the water scarcity issue. The power failures are tackled by having 100% off-grid energy generation with a battery backup for 15 days of harsh weather. Also, use of net metering will help us to give the extra generated energy to the grid. To resist the harsh temperature and create a thermally comfortable environment, various passive and active strategies are used, which that maintains the indoor temperature up to 18 to 20 degrees Celsius. By excavating the site, the raw material, that is the earth, is generated, which eliminates the cost of construction, further reducing the transportation cost. We have reduced the cost for the MEP services between the base case and design case, as we shifted from the electric radiant heating system to hydronic radiant heating system. The material use and other costing is the same for the base case and design case. Comparing electric and hydronic heating system, we have chosen the hydronic system over the electric system, as it is more beneficial and suitable for our project. So the cost per square meter is reduced by rupees 1018, and hence the final cost of Nilaya housing is around 6 millions. After consulting the local contractor, the project is expected to complete within 5 to 6 months, considering the harsh climate of 2 months of January and February. Market potential: the use of locally available and on-site generated materials such as stone, wood, mud, and wool will help us to promote the local traditional construction market. It would also generate revenue for the local masons and result in faster construction. This all in turn will increase the local market and would help to resist the change in market. This would become an ideal project for the upcoming housing sector in Leh, all of which would in turn to be a boon for the economy of Leh. Scalability: by creating a net zero structure with a blend of traditional vernacular architecture of Leh, we are creating a ideal single family house in Leh. The modules are arranged in the group of 8, forms a community. This can be replicated with some modifications into various different parts around the Leh region. The main motto is to promote this idea in various parts of country of blending the traditional vernacular architecture with modern techniques to achieve a net zero approach. Through Nilaya Housing, we have achieved a net zero house which has a blend of its traditional vernacular architecture. We have achieved operational design with inclusion of basic engineering technologies. We have achieved optimum indoor temperature to maintain the thermal comfort in extreme climatic conditions. We have conserved the traditional heating system Bukhari, making it smokeless, and innovation in building material to achieve the desired thermal insulation. We have achieved the EPI of 66.08 kWh per meter square per year, considering a benchmark of 100 kWh per meter square per year, with 95% of net zero energy solutions. We have achieved 85% net zero in water supply and reuse. We have effective waste management achieved with usage of same as manure in the agricultural fields. We have achieved effective building resilience against the earthquake, thermal issues, water scarcity issues, and the energy generation. We have achieved affordability through usage of local materials, masons, and local strategies. We have replicated the module at the regional level with some modifications, ensuring scalability and increasing the revenue to raise the market potential. We team members thank you our faculty lead for their valuable guidance. Uh, we thank our lead institute, Brick School of Architecture, Pune, and the other institute, Pimpri Chinchwad College of Engineering, Pune, our project partner, Asim Foundation, industry partner, VKE Environmental, and Solar Decathlon India to provide us this platform. Thank you.
Thank you very much, team. You've definitely finished within the given time frame, and it was also a very interesting presentation. I must be saying that. So we finally reached the point where I'm going to hand it over to the jury one by one. So we'll start with you, Venkatesh. Please go ahead.
Team Arnima, great job. Your presentations were always something that I looked forward to for various reasons, right? And I mean, the best thing I liked about it was your costing. Your zero energy, zero water buildings seem to cost less than a regular building. So if your partner ends up not being able to sell one of those houses, let me know. I'll be interested. Okay.
Yes, sir.
The only problem I have with you is that you have taken a cookie cutter approach for the layout. I mean, everything looks like you just kind of plumbed it. I really wish you'd put a little more thought into that, which have really added a lot more value. But some great design options. I really liked it. It was culturally very sensitive. I love that prayer room, that green room, the dry toilet. But I think the best part was the biogas and the cattle. The duct for taking fall smell out and covering it with a trombone is again a very clever, simple but clever idea. Radiant heating was again a brilliant idea in my opinion. But a few questions. Your water balance did not show us where you get water for the cattle from. Okay, I'm not sure about it. Now, if you add that, I don't know whether it would tweak your balance, right? Because I assume that you're getting water only from the monastery. That's the only source of water apart from the ice stupa, correct? So that was one thing. And you seem to be taking back a lot of the excess grey water back to the monastery for recirculation. So I was mentioning that there should have been an intermediate holding tank for that because you really can't take that water and mix it with fresh water coming from the monastery. I didn't see that comment addressed in your subsequent presentations.
Sir, uh, can I say something?
Yeah, go ahead. Yeah.
So the water from the filtration system does not goes back to the monastery. Instead, firstly it is stored in an underground tank. Then again it is pumped to the OHT tank. It does not goes again to the monastery. It goes to the
Yeah. Okay.
OHT
So
at the community level.
correct. Yeah. So I just was wondering whether there should have been two OHTs, one for the fresh water from the monastery and one for grey water. Because I just saw one OHT. So I mean that was my comment, right? Dependence on wood. I don't know whether you guys can examine options for wood. I mean, it's a great thing, but wood is really not the most scalable, right? I mean, you have a cold desert, you have limitations on wood, and you start using more and more wood. Then I don't know where you're going to end up with. On the whole, it was just a wonderful thing. I really loved your report, and I really hope you guys did your costing exercise well, because, like I said, if you guys are really cheap, let me know. I'll be interested in buying one of your projects because your project is a prime and a great example of something that can actually go get built, right? And I
Thank you, sir.
being part of this competition, whether you eventually win or lose, come first to second, third, whatever, doesn't matter. It's what you learn, what you take back. And I really wish you power so that you're able to build this actually and learn from that. Okay. Best wishes. Great job.
Yes, thank you, sir. Thank you, sir.
Thank you so much, Venkatesh. Shelly, over to you now.
So, yet again, I think your site was quite unique. I would start with that. Even I thoroughly enjoyed reading your report. You have not just implemented one innovative strategy, I think there were multiple of them, starting from dry toilets to ice stupas, strong walls, and whatnot. And one of the most important things that I really liked about your design was the sense of community that you're trying to bring in, that how you're also thinking about generating the excess energy and giving it off to the communities. And even from the water perspective, like the excess water being generated through the ice stupas, you're trying to give it back to the community. So I think that sense of bringing people together was something which is very, very unique to your project. So congratulations on putting it all together so well. In terms of the comments, I was just thinking that in terms of renewable energy generation, you're saying 85% of it is through the biogas and 15% of it is through the solar disk. So I just wanted to, I felt that maybe the calculations are slightly missing. So it would be really good if you can add some calculations as to how much of energy you're actually producing using the biogas, and whether you have that much of availability of the resources, which, and the entire system, how is it going to work? And the same thing goes for the solar energy generation as well. I felt that you could also add some sort of evidence as to whether these numbers are able to cater to the energy which the building is actually asking for. So that was one thing. And then, of course, later on, the things come when you talk about community. So that was one generic comment. The second question I had was with respect to the ice stupa calculations, the water calculations that you're showing. So I believe that you're saying that there is 45,000 of liters which is getting generated and used up by your own site. And then versus there is total generation of close to 2.3 lakh, which would be able to cater to 2,200 people. So, I mean, could you please explain these calculations a bit to me? I think that probably the numbers were on a bit higher side, considering that the 2.3 lakh of water is being generated in the span of 2 months, if I'm not wrong, which is April and May.
Actually, ma'am, like the water
No,
comes
ma'am,
from.
in the span of 4 months.
Okay. Okay, so in the span of 4 months, there will be close to 2,200 people who will get benefited from this.
Yes, ma'am. The ice stupa will
Yes.
work from like the freezing of the water will be from November to March, which is the cold winters, and
Mm-hmm.
after the early summers, the ice start melting, and this water flows for 2 months.
Okay, okay, all right. Then I had just one more quick comment. So, thinking of comfort, I just had a look at your daylighting contours that you had shown. So, first of all, I think it will be also good to look at it whether those numbers are adequate or not, because I think a statement is being made that the space is well lit. But if you just look at the scale currently that you're being using, it starts from 22 lux to I think goes on to some thousands. But the color contours that you're using is starting from yellow. So it seems like, I mean, you perceive the space to be very well lit. But I think if you change the color contours and if you try to zoom in and see, then that would make more sense to actually map the lux levels that you're getting throughout your floor plate. And also, please try to look at the standards, like whether those levels are adequate or not, depending on your space type, whether it's living room, bedroom. Like you can also, plug it to existing standards and see whether those numbers are like how much of actual comfort they are able to provide. And then, of course, you can always think about taking a step ahead and use some advanced metric like SDA, maybe the spatial daylight autonomy, which also talks about the quality of light, because it's not necessary that always to have very high lux levels is good, because that can also cause some sort of discomfort. If the values are way high, it can also result in some sort of glare. So I think that was also one of the comments that I had for daylight. But otherwise, I feel this is probably one of the most interesting presentations that I've come across. So congrats on that.
Thank you so much, Hedy. Saswati, over to you now.
Yeah, thanks. So great job, guys. And I almost missed the beginning of it because of an internet issue, and I'm so glad it came back on time. A few things that I would like to, commend you on. I think in your presentation, you have kind of moved a step ahead from where you were in the report. I could see you addressing some of the comments to the extent possible. I don't know whether you had done it already, been working on it, or whether you did it within these 7 days that you got. But there was definitely a step ahead in this. So congratulations, big, good work on that. And I would also like to commend you on the on how you did the presentation. I mean, there's one thing where you just put in whatever from the report and put it into a presentation and figure out how to do it. But there was a structure to how you presented it, so that even if some of the calculations or numbers might be a little weak, but at least the concept of what you were doing was clear to the audience. I mean, we are there is a whole range of people watching you, right, who are not technical people. So that was very good, and I really appreciate that a lot. And one small thing I just noticed is that I got to hear mainly Yash and Rutuja. I did not get to hear, maybe because I was out for some time. But I could see that there was a lot of, how do I say, underlying moral support going on. I could see Yash nodding when Rutuja was presenting and everything. So shows good teamwork, great teamwork. So that's great. And apart from that, I would just say that if I mean, both Venkat and Shelly have talked about the innovations that you are looking at. I can, like our organization would love to, if you want to pursue this further and, look at certain numbers, especially regarding the energy numbers and how you're dealing with the radiant heating and the Bukhari heating thing. If you would want to relook at those designs, I mean, we'll be glad to help you with that.
Yes, ma'am. Surely we will look for that.
Yeah.
Thank you.
So, thank you very much. Thank you to the jury and thank you to the entire team. It has definitely been a very excellent presentation. So, I think a big round of applause for all of you.
Thank
All
you,
of us.
ma'am. Thank you,
So,
sir.
please sit back and enjoy. We're going to get to the next presentation. So, jury, I'm going to give you 5 minutes, but please stay backstage. In the meanwhile, we'll get next team ready.
Great. Best
All the
Thank you, sir.
best.
Thank you, ma'am.
Yeah. Welcome back, everyone. So it's finally time to move on to our next presentation, which is going to be delivered by Team Amigos. They have worked on Chintamani's house, which is located in Jaipur, alongside their project partner, Mr. Arvind Chintamani. So I'm going to run a very quick AV check with all of you. I'm going to take your name one by one. Please unmute yourself and say hi. Okay, I'll start with you, Yashraj. Hello.
Hello, ma'am. Good morning.
Hi. Perfect. Hi, Sanskar. You've not unmuted yourself. Please unmute so that I can check that. Okay, I'll unmute you from the back end. Yes.
Hello, ma'am.
Hi.
Hello, ma'am.
Hi, Ankit. Ankit, can you hear me?
Hello, good morning, ma'am.
Yeah, hi. And hi, Akanksha.
Hello, ma'am. Good morning.
Hi, perfect. I think now we're all on the same page. So, very quickly, a few instructions while we share your presentation with everyone. You are going to have 25 minutes to be presenting, where at the end of 20 minutes, I'm going to make a very slow sound so that that gives you a reminder that you have only 5 minutes in your kitty. And if at all we do reach the 25 minutes mark, I'm going to jump on screen and stop you right there and then. That's the first thing. Second thing, we have our 3 jury members here with us listening to the presentation. They'll be joining us at the end, and we'll have a Q&A round that pans across 15 minutes. So that's all you need to know. All the best. The stage is all yours now. Please begin.
Good morning to all the jury members and all the audience listening to us. I hope the jury members are comfortable with both English and Hindi, as we'll be presenting in a mixed language. May I please confirm, are the jury members comfortable with both English and Hindi?
I can confirm on their behalf, yes, they
Yes.
are.
Yes. Okay, all right, all right. We are Team Amigos, and we designed a residence for a family of 2. Mr. Chintamaniji is the owner of the house, residing with his wife in Jaipur. He is an retired electrical engineer. The owner's requirements were very simple. He wanted to conserve the natural vegetation on the site and incorporate proper daylighting in the building, and of course, make it affordable too. The next is the next, please. The next is the site introduction. A plot is spread across 306 square meter of area in Akshat Kanauta, Agra Road, Jaipur. The plot is located in hot and dry climate with temperatures soaring as high as 45 degrees Celsius and humidity very low 10 percentage. The corner plot is approached by 9-meter wide road from east as well as outside. Next. Yes, now I'll jump on the site analysis. A site was covered with wild plantation with khechri tree at the south of the plot, along with neem and kasul tree at the periphery, with services line already built on the plot because it is situated in a township named Akshat Kanauta. Now I hand over to Sanskar. Yes, we already did this slide. Sanskar, please next.
Now let's come to the resilience. Uh, we have identified the 6 There are the 6 key areas are the optimizing energy performance of the building, indoor water use reduction, heat isolation reduction, outdoor water use reduction, renewable energy, and rainwater harvesting. Now, these 6 criteria are also certified by the regional priority credit, and these are the 6 factors which we have identified in our locations. So for optimizing the energy performance of our building, we have appliances has been selected on the basis of Bureau of Energy Efficiency Rating Scale. These appliances were chosen. Most of the appliances were chosen on the 5-star rating to reduce the total equipment load of the building. For the reduction of water, the dual flush toilets and the low flow aerator taps were used, which save up to 50% of the total water consumption. Also in our township, we get the supply of treated water from the water treatment plant, which were used for flushing and landscape purpose. Also used for efficient. Also, we know that the washing is the one of the major water consumption work in a house. So to reduce the water consumption in washing, we use the efficient water machine, from which our water consumption reduced to the 50%. Also, one of the another challenge is urban heat island reduction. For this, we have used the ceramic tiles with high SRI value paint to on the terrace floor, where we have created a terrace garden to reduce the urban heat island. For outdoor water reduction, we have used the pot irrigation system, which is an water efficient irrigation system. And also we have created the channels on the pathway of the surrounding to promote the groundwater recharge. Now coming to the rainwater harvesting system. In our project, the rooftop water was harvested and stored, where the water from remaining site is taken to the recharge pit. Now renewable energy. We have used a solar plant of 5 kilowatt ampere, which generate the 19 unit per day and 7,000 unit per year. Now handed over to Akanksha.
After analyzing the complete site, quality of space, we took into consideration some basic, simple techniques for idealizing the design. We designed the house around the existing khejri tree in the north. We developed the project with traditional methods and a straightforward approach to the design. Next, please. The openings in the courtyard wall ensure natural ventilation of the central hall. Exhaust fan makes certain the forced ventilation in the east facade. Warm air escapes through the punctures, cooling down the indoor temperature. Next, please. Natural and cross ventilation in the house is ensured uh, through openings throughout the house in the necessary locations. Next. Sufficient visible daylight to the building without any glare is ensured from the curtain wall of the north and the south facade. The microclimate within the house was maintained through such cultural and traditional design. Next, please. These are the basic architectural drawings of our project, the section and the elevation. We have showed the east elevation and the south elevation. Next. These are the details of the slope roof, that is the pronto shades with double insulation, the internal wall and the detail of the curtain wall. We used 8-bay 3-phase distribution board in our project for less load on the main distribution board for better work efficiency. The pitcher in the pot irrigation system is a self-watering technique in which the water inside it sifts through the porous surface to the nearest soil and the plants take up only the required amount. The pot can store water for about a week. This avoids wastage of water as well as unwanted evaporation of water. This operation is a low-cost technique as well. Next. Channels are created in the periphery of the site that collect the site water and further transfer it to the recharge pit. The graded pathway ensures good indoor environment quality by screening the house from dirt that might be carried out by the occupant's footwear. This is a part of health and well-being as well. Over to Ankit.
For energy performance, the following data is considered and analyzed. In, in summer, the temperature goes from 22 degrees Celsius to 43.5 degrees Celsius, and in winter, it ranges from 4 degree to 27 degrees Celsius. But the current scenario has changed. The temperature goes up to 47 degrees Celsius because of heat waves and climate change. And here, the direct normal range of radiation is varies from 1200 to 10,000 1200 watt hour per square meter per day. So we are talking about building envelope. We have used AAC block instead of brick or other material because we got 1 degree Celsius temperature difference, and to make it is favorable to human comfort, we have further make changes in wall sections, roofs, windows, and shading devices to achieve a optimal temperature difference. We have used reflective coating in exterior side and gypsum, then AAC block and XPS insulation in walls and roof. We have used in roof we have used Panasi green. Okay. So in shading devices, we have used vertical and horizontal shading devices, which makes 1.5 degrees temperature difference. And we have used also curtains, curtain lace, which reduces 71% solar radiation and 90% ultraviolet rays. Next. So talking about summer analysis, this graph is showing the temperature schedule, which this is showing justly from midnight to 10 a.m. and 5 p.m. to 11:59. This is so basically it is about the temperature, outside temperature and inside temperature. What we achieved through our simulations when the outside temperature was 31 degree to 43 degrees Celsius between these time that is showing here. So we achieved 26 degrees to 28 degrees Celsius with our design strategies, and when the outside temperature was 39 to 44 degrees Celsius between 10 a.m. to 5 p.m. as shown in graph. So we achieved 27 to 36 degrees Celsius. So the conclusion was of this graph is the time duration between 12 noon to 4 p.m. the temperature was not in favorable conditions. So we are going to use HVAC to make it hum, to make it to make this temperature in human comfort. For talking about winter analysis, तो हमने इसमें आउटसाइड टेम्परेचर 7 डिग्री सेल्सियस था, और हमारी डिजाइनिंग स्टडीज से हमने इसे 90 डिग्री सेल्सियस अचीव किया हुआ है, जो कि लेकिन जो कंफर्ट बैंड हमारा 20 डिग्री से 30 डिग्री सेल्सियस वेरी करता है, जो कि अकॉर्डिंग टू सोलिडिफिकेशन मॉड्यूल्स के अकॉर्डिंग है ये। तो ह्यूमंस की मोटाबिलिटी रेट एंड पर्सनल फैक्टर्स के अकॉर्डिंग 1 डिग्री सेल्सियस को मेंटेन किया जा सकता, मतलब वो चीज़ बैलेंस की जा सकती है पर्सनल फैक्टर्स के अकॉर्डिंग। So we don't need HVAC for this winter analysis. Next. Daylighting analysis. In our project, we got daylighting in kitchen 600 lux and drawing room 666 and dining room 900 and bedroom A 733 and bedroom B. These are achieved lux that we got from our analysis. Next. Okay, after this what we got temperature, but there was some temperature difference. We don't get set changing. We have here for unfavorable hour we have used HVAC system. तो हमने इसमें वी आर वी सिस्टम यूज किया है जो कि कपल्ड है सोलर पैनल से, जिसकी कैपेसिटी 610 है। और इसके वी आर वी से हम बेसिकली इंडिविजुअल स्पेस के टेम्परेचर्स को मेंटेन कर सकते हैं। ये एनर्जी एफिशिएंट है एंड इसका इंस्टॉलेशन इजी है और कॉम्पैक्ट इन साइज है, तो हमने से इसलिए यूज किया है। नेक्स्ट, फॉर एनर्जी जनरेशन, after consulting from Tata Solar, we have used 16 module solar panel, which requires a 50 square meter surface area, which capacity is 4 kilowatt, and each plate is of 320 watt. So our consumption is decided with a 5-star rating appliances and services like VRV. So we generate with the solar panels 19 unit per each per day, and with surpluses is 4 unit per day. Water performance. Over to you, yes, sir.
Yes, Ankit. Now we'll be talking on the water performance of the building. Next. Jaipur is currently experiencing growing water scarcity and diminishing drinking water sources. Jaipur relies extensively on groundwater and single surface water source, which is located 120 kilometers away from Jaipur. According to NBC, water consumption is 135 liters per capita per day. We have reduced the water consumption to 75 liters per capita per day. Now, how did we do it? Sanskar, next please. Below are the few strategies and techniques used in water reduction. Like in the case of washing machine, we used a 6 kg front-loaded washing machine which uses 70 liters of water. The number of days machines were used were 2, so the total water consumption is 140 liters for 2 persons. So the average out comes to 10 liters per capita per day, which reduces the water consumption to half. Next, please. I missed a few points which I'll be discussing right now. Like in the flushing, we are using dual flush WC. In bathing, we are using low flow aerators. And some behavioral changes and awareness is also required to conserve water and save water, such as in cooking purposes. Next. Okay. So I'll be talking back. Yes. So 45 liters out of 70 liters has been catered from rainwater harvesting. The given data is the average harvesting potential of 5 years of rainfall in Jaipur. During the month of June to September, we have rainfall which generates a runoff suitable for harvesting. Next, please. 90 liters of rainwater for 2 occupants is used for daily usage. Water needs to be stored for 9 months as harvesting cycle can start in June every year. 25,200 liters rainwater is required to be harvested for yearly usage for 2 occupants. Rainwater is being harvested from terrace and the site water is being used for groundwater recharge. Rainwater tank, next please. Rainwater tank of 25 cubic meter is proposed on the front setback of the plot. So as I told you, the rainwater is collected from the terrace of the plot. Next please. Grey water generated at the site is sent to the STP, which is located at our township, Akshat Kanota. And the treated grey water is used in flushing and landscaping. And this is the graphical section of the rainwater tank and the recharge pit which we are providing at the front setback of the plot. Next. Sanskar, over to you.
इलेक्ट्रिसिटी हेलो। जैसा कि हम जानते हैं कि हमारे प्लॉट पे जो हमने इलेक्ट्रिसिटी जनरेट की है वो हमने 4 यूनिट हमने अपने कंजप्शन से 4 यूनिट ज़्यादा जनरेट की है। तो अगर इन द केस हमारे मतलब अगर सिटी में या टाउनशिप में कभी कटआउट्स होते हैं तो हमारे पास 96 डेज की टोटल एनर्जी होगी इलेक्ट्रिसिटी के रूप में। और अगर वाटर की बात की जाए तो हमने जो रेन वाटर हार्वेस्ट किया है तो हमारे पास 876 डेज के लिए रेन वाटर अवेलेबल होगा। नाउ वी आर टॉकिंग अबाउट अफोर्डेबिलिटी। तो अफोर्डेबिलिटी की अगर बात की जाए तो हमने सबसे पहले लोकल मटेरियल्स पे ध्यान दिया है। अपने बिल्डिंग एनवेलप सिलेक्शन पे हमने सबसे पहले लोकल मटेरियल्स पे ध्यान दिया है, जिसपे हमने एसी ब्लॉक्स का सिलेक्शन किया। उसको सिलेक्शन करने के पीछे क्राइटेरिया ये था कि एसी ब्लॉक इन कंपैरिजन टू ब्रिक कॉस्टली तो होते हैं, बट जब हम इसका इस्तेमाल करते हैं इनकी डायमेंशंस को अगर देखा जाए तो ब्रिक के कंपैरिजन में इसकी डायमेंशन 3 टाइम्स होती है। तो हमारा जो कंस्ट्रक्शन स्पीड है वो भी बढ़ जाता है, फास्ट हो जाता है, और हमारे जो कॉस्ट है, लेबर कॉस्ट है, वो भी घट जाती है। हमारा जो क्वांटिटी है उसकी एसी ब्लॉक की वो भी घट जाती है। इन सब क्राइटेरियाज को अगर ध्यान से देखा जाए तो ओवरऑल कॉस्टिंग जो है वो हमारी एसी ब्लॉक लगाने के कारण काफी ज्यादा कम हो जाती है। फिर हमने अपने प्रोजेक्ट में काफी सारे लोकल मटेरियल्स इस्तेमाल किए हैं, जैसे कोटा स्टोन और स्लेट स्टोन हमने अपने पेरीफेरी में जो कोर्टयार्ड बनाया वहां पे इस्तेमाल किए हैं। सेरेमिक टाइल हमने टेरेस गार्डन पे इस्तेमाल किया है। इन सब की अगर इम्पोर्टेड एनर्जी की बात की जाए तो ये सेरेमिक टाइल की अगर बात की जाए तो वो 2500 होती है। एसी ब्लॉक की अगर बात की जाए तो वो 155 होती 10 and 55 होती है। कोटा स्टोन की अगर बात की जाए तो वो 500 होती है, और स्लेट स्टोन की अगर बात की जाए तो वो 2500 होती है। अगर हम एसी ब्लॉक और ब्रिक के कंपैरिजन करें तो अगर हम अपने वन फ्लोर की वॉल बनाने के लिए अगर हम कोशिश करते हैं तो हमें नंबर ऑफ ब्रिक्स जो है वो 5193 ब्रिक्स लगेंगे। बट अगर उसी वॉल को हम एसी से कंस्ट्रक्ट करें तो हमें 1/3 ऑफ ब्रिक लगेगा, 1/3 ऑफ द ब्रिक लगेगी। और अगर कॉस्ट की बात की जाए तो 230 की थिकनेस की वॉल बनाने के लिए हमें 230 की थिकनेस की वॉल बनाने के लिए हमें ब्रिक का एसी ब्लॉक का कॉस्ट पड़ेगा 1187 स्क्वायर मीटर। बट अगर हम ब्रिक की बात करें तो उसका कॉस्ट पड़ेगा 1154 पर स्क्वायर मीटर। और अगर एसी के मेजर बेनिफिट्स की बात की जाए तो 50% लाइटर होते हैं रेड ब्रिक से, फायर रेजिस्टेंस होते हैं, उसके थिकनेस पे डिपेंड करता है वो कितना फायर रेजिस्टेंस है, बट मोर देन 2 to 6 आवर्स होते हैं। रिडक्शन फिर 25% रिडक्शन होता है एयर कंडीशनिंग कॉस्ट में। थर्मल एफिशिएंसी होती है 3 टाइम्स हायर होती है क्ले ब्रिक से। वाटर एब्जॉर्प्शन जो होता है वो 10% होता है इसके वेट्स का। तो हमारा प्राइम ऑब्जेक्टिव था इकोनॉमिकल कंस्ट्रक्शन मटेरियल का जो हमारे एरिया में अवेलेबल है उनका इस्तेमाल करना। तो ये एसी के कुछ बेनिफिट्स हैं जिसको ध्यान में रखते हुए हमने इस्तेमाल किया है। जब हमने अपने प्रोजेक्ट की लाइफ साइकिल कॉस्टिंग निकाली तो जो क्लस्टर कॉस्ट था वो हमारा 3.93 मिलियन था, और जो प्रपोज था वो 4.12 मिलियन था, जो कि उस टाइम पे पहले ज्यादा था। बट जब ऑपरेशनल कॉस्ट की बात आई, जब हर 5 ईयर्स में इसकी ऑपरेशनल कॉस्ट और रिपेयर एंड मेंटेनेंस की जब हमने बात की तो हर पहले 5 साल में हमने 0.02 मिलियन सेव किया। उसके बाद 10 साल में हमने 0.16 मिलियन सेव किया। 15 साल में हमने 0.33 मिलियन सेव किया, और ओपेक्स रिपेयर मेंटेनेंस में हमने 0.043 मिलियन सेव किया। तो जो हमारा टोटल बेस अमाउंट था वो हमने 12 ईयर्स में ही अचीव कर लिया, और उसके बाद हमने प्रॉफिट किया 5.83 मिलियन का। Now over to Yash.
Thank you, Sanskar. I'll be talking on the scalability and market potential. We have targeted local market on the basis of new construction and existing building. हमने 1 किलोमीटर के रेडियस में सर्वे किया था मैनुअली, तो हमें पता चला कि जो रेशियो न्यू कंस्ट्रक्शन और एग्जिस्टिंग कंस्ट्रक्शन बिल्डिंग का वो 1:10 है। सो द मेजर हमारा जो एरिया टारगेट है दैट इज द ओल्डर कंस्ट्रक्शन एग्जिस्टिंग बिल्डिंग। So our target market is building owners. We are providing solution and consultancy to this problem by introducing our techniques. Some of our techniques that we have used in our design and are scalable to the market are, next please, sequence of graded pathway. Charlie, how do we scale them? Like by establishing a nursery, we can sell plants which are insect repellent plants, aloe vera to maintain IAQ and interior decor. Now, Stone Charlie, we can prefabricate on the site as well as in the factories, and we can scale them faster. Next, we can even provide local labor training program to train the laborers to develop their skills. Next, please. Now we were talking about.
Now we were talking about the social media and the communication. So we were used the social media as a mode of the communication to spread the awareness among the people about the importance of net zero building. So as you see, we have shared some posts and how we have achieved how we have achieved our aim to spread awareness among the people about the importance of net zero building. Also, we conducted sessions on net zero building in our college to spread the net zero building importance in youth among the youth generation. Thank you.
Thank you to the jury members for listening to us and providing us the platform. Thank you so much.
So, very thank you to the team. You've definitely finished within time, and it was also a very good presentation to be listening to. I'm going to hand it over to the jury now quickly for the Q&A round, and we are going to begin with Venkatesh. So, over to you.
Yeah. Good work, team. You guys have put in a very compelling design. It was really nice. I personally love that touch of the tree. You know, the Kejri or the Shami is closely associated with Indian mythology, and it's always nice to have something which is rooted in tradition, which is very nice. You didn't touch upon it in the presentation, but your idea of having those little openings on the east wall for venturi effect was again a very good idea. I don't know whether you touched upon it or whether I missed it, but I didn't pay attention to it here. The pot irrigation is also a very smart thing to do. I also appreciate the fact that we made a comment saying that you didn't make a compelling costing model in our report, and you seem to have worked on it in this presentation. So that is again something which is very good. This is a question on that lace curtain, right? And which probably my colleagues in the jury, Shaili and Shashwati, could probably add upon. You have that lace curtain inside. You say it absorbs a lot of heat, etc., etc. Why would you put it inside the house? I mean, you're letting the heat come in and then you're absorbing it. So the heat is still inside the house somewhere, right? Could you not have thought of some way of putting it outside the building, like in the olden days when you had those cane curtains, so that you're kind of cutting it off outside itself and improve your energy performance? I don't know if that's something that you can actually look at. And those daylighting levels that you're talking about, when some of it is like really high, right? 900 lux and all that. I mean, it's just kind of crazy. I don't know. You guys seem to have these little momentary moments of lapses of good reasoning, but it's really a good job. And what is nice about it is you kept it to very simple tricks, simple tweaks, like courtyards. You had the kitchen on one side of the courtyard and the master bedroom on the other side of the courtyard. So it kind of gives you the privacy and yet allows the security to be in place for a house when it works that way. But that huge window on the master bedroom on the west without any shading was a little bit careless in my opinion. I don't know whether you addressed it in the subsequent designs or not, but I don't know why you would have such a huge window on the west in the master bedroom. On the whole, it was really a very good Very good design. I really liked it, and it was a straightforward approach. There are no big tricks. Your water calculation, the way you stored the excess water, you peaked your storage capacity around those months of June to September, and didn't really break your head about the other months. Was all, I think, pretty smart thing to do. So I think you got a very compelling design to take to market, and I think on the whole you guys have done a pretty good job. I mean, I just love the ideas of the courtyards, a huge terrace on the first floor for winter sunning. The constant reference to air conditioning in winter was something which I found a bit jarring, but I don't know why you would want to do it, but good job, congratulations, you guys have done a really nice job, and I hope your client likes it enough to build it.
Thank you
I'm
so
just
much. Sorry. Yeah, thank you, Venkatesh. I'm going to go on to Sherry now.
Okay. So congratulations, team. I too would kind of say the same things that just Venkat mentioned. I think you have tried to blend in the elements of aesthetics very well, along with the performance of the building. So this creating those small punctures and trying to get to the Venturi effect was one of the examples of that. But moving on to the technicalities, I feel it's a pure physics-based concept. So let's start with that. So this effect, you first need to understand whether it will work or not, because it requires certain amount of pressure differential, whether you would be able to achieve it, owing to the wind direction and the wind speed and all that is something that you have to study more thoroughly. So that is one thing. Second is that you also need to understand the kind of hot air that you're bringing in, whether it would be good enough to provide the comfort to the people inside. Because being in Jaipur, of course, the external conditions are going to be a bit harsh. So you also have to figure out that how many hours it would be comfortable for you to actually bring in the outdoor air in. And in reality, how much of temperature drop are you able to achieve through this effect? So these are some practical questions that will be really good if you can, kind of nudge yourself and take a step further and think of it more from a physics-based principle and kind of look at it that way also. That was one of the points. Second was in terms of your energy consumption, I felt that the EPI number also, it would be good if you could please add, because I felt that those numbers were slightly missing. एंड मतलब एक और पॉइंट ये भी है कि जब आप डे लाइटिंग की बात करते हैं, आई थिंक आपकी स्पेस बहुत ही वेल लिट है, सो दैट इज़ गुड थिंग. बट अगेन जब आप ज़्यादा बड़े विंडोज़ देंगे तो उसकी वजह से हीट भी बहुत ज़्यादा आती है अंदर. सो इट्स ऑलवेज अबाउट ऑप्टिमाइजिंग हीट वर्सेस डे लाइट. सो इट इज़ वन ऑफ द चैलेंज इन जयपुर. सो मैं इसके रिस्पेक्ट में भी ये चीज़ आप लोग को सजेस्ट करूँगी कि मतलब यू कैन अगेन स्टार्ट विद अंडरस्टैंडिंग द वेदर एक्सटर्नल, मतलब कितने टेम्परेचर रेंजेस हैं या फिर आपका सोलर रेडिएशन कितना आ रहा है. सो दैट विल हेल्प यू टू डिज़ाइन और टू काइंड ऑफ make your design more robust and to kind of provide more strength to it. That would be one thing. And दूसरा जो just one small question that I had was कि आपने एक wall का cross section दिखाया है जिसमें wall AC brick use किया है, उसमें XPS आपने 12 mm का use किया है on the outside I think. So अगर आप वो slide पे वापस जा सकते हैं please. I just wanted to know why have you kind of selected that. It's a very different kind of wall cross section that I've seen, because you're integrating it with gypsum plasterboard on the inside. So yeah, this one. So on the left, हाँ, so यहाँ पे XPS insulation आपका 12 mm है and gypsum plasterboard अंदर के side use हुआ है I think. Or if just please correct me if I'm reading it wrong.
हेलो
हाँ.
मैम, इसको डिफरेंट मटेरियल्स यूज़ करने का रीज़न ये था कि हमारे यहाँ राजस्थान में एक तो रॉस कंडीशन है, जिस वजह से अगर सिर्फ एसी यूज़ करेंगे तो हम लोग वो जो डिज़ायर ऑप्टिमम टेम्परेचर है वो हम रिसीव नहीं कर पाएंगे. तो डिफरेंट ये लेयर्स को यूज़ करने का, जैसे एक्सपीएस को एंड जिप्सम वगैरह को इनके यूज़ करने से तो हमारा जो टेम्परेचर था वो ऑप्टिमम हम लोगों ने अचीव किया है इसको यूज़ करने से.
अच्छा. क्योंकि
This is
इसकी
why
वजह
we
से ये
use
भी
it.
ओके, सो आप इंसुलेशन सारे वॉल्स में प्रोवाइड कर रहे हैं पूरे कंस्ट्रक्शन में,
No,
या
मैम
फिर
mainly
ये
मैम,
किसी
हाँ,
ओरिएंटेशन पर ही है, मतलब आप ये
मतलब
इंसुलेशन
जैसे
सारे
नॉर्थ ईस्ट वगैरह वाली वॉल है जो कि सन से ज़्यादा एक्सपोज नहीं है, तो वहाँ हम लोगों ने नहीं यूज़ किए। जैसे ईस्ट साइड हुई एंड वेस्ट साइड हुई, तो वो सन से ज़्यादा एक्सपोज करती हैं, तो उन
ओके
पे हम लोगों ने इसको अप्लाई किया हुआ है।
ओके ओके, नो आई मीन इट्स बेटर, क्योंकि आप किसी एक ही जगह पे इसे अप्लाई करें, बिकॉज इसका कॉस्ट इम्प्लीकेशन भी पड़ता है। अगर आप सब जगह पे अप्लाई करेंगे तो प्रॉब्ली ज़रूरी नहीं होता है। दूसरी
यस
चीज़ ये भी है कि इसका जो थिकनेस होता है ये भी एडिक्वेट होना चाहिए। सो आई डोंट नो, आपने अगर आप चाहते हैं तो इसमें फीजिबिलिटी स्टडी भी हो सकती है कि 12 mm एडिक्वेट है या फिर 25 mm है या फिर 50 mm है। सो बेस्ड ऑन दैट भी आप इसको थोड़ा ऑप्टिमाइज़ कर सकते हैं, बिकॉज अभी का जो थिकनेस है ये थोड़ा कम है। सो आई मीन ये आपको कितना एडेड वैल्यू प्रोवाइड कर रहा है वो भी आप चेक कर सकते हैं। अगर नहीं तो यू कैन टोटली एलिमिनेट इट ऑल्सो, that could be one of the
मैम
options, because it's
जो हमने
always has
हाँ
हाँ
मैम जो हम लोगों ने एनालिसिस किया था, तो हमारे पास कूलिंग डिज़ाइन का जो शेड्यूल निकल रहा था, तो उसमें 12 AM to 4 PM, जो कि आउटसाइड टेम्परेचर हमारा वेरी कर रहा था 38 to 44 डिग्री सेल्सियस। तो इसको यूज़ करने से, जो मटेरियल्स यूज़ करने से हमारा बाकी जो रेंजेस थे हमारे मतलब शेड्यूल था, उसमें हमारा ह्यूमन कंफर्ट के रेंज में आ चुका था। लेकिन इस शेड्यूल में हमारा टेम्परेचर बिल्डिंग का 36 डिग्री के आसपास जा रहा था। तो दिस बार और हमने इसकी थिकनेस बढ़ा के भी देखी थी, लेकिन फिर भी इतना ज़्यादा मेजर चेंजेस नहीं आ रहा था, और फिर हमको इसके लिए HVAC शेड्यूल करना, मतलब ऑप्शन रखना पड़ा था।
okay
और
no
हमारे जो यूज़र हैं वो एज्ड हैं, तो उसके लिए वो लोग शेड्यूल्स को याद नहीं रख सकते, तो कि उनको कब HVAC यूज़ करना है, कब फेवरेबल आवर्स में टेम्परेचर लो रहेगा, कब हाई रहेगा, तो उसके लिए हम लोगों ने ऑटोमेशन यहाँ दिया हुआ है, जिससे कि एक मैनुअल ऑप्शन भी रहेगा, जैसे जो भी अगर अनफेवरेबल टेम्परेचर है, अगर उनको फील होता है तो वो उसको ऑपरेट कर सकते हैं।
okay okay no good, I think ये अच्छा अप्रोच है, so good, but overall good job, I think design wise, performance wise, very nice.
Thank you, Sherry. Saswati, over to you now.
Yeah. So congratulations to the team, and this is so much better than what the report had come, because the report was उसमें काफी gaps थे. I mean, the context and everything was not very evident in the report. I mean, the first page से अगर आप start करो, I was not able to figure out where the project was located also. So the presentation, if I say it's way better than what the report has been like. And I was just checking some things. So some of the comments have been addressed, as Venkat also said, and I also saw something where, you know, about the roof construction ke bare mein comment tha, that the wall has been insulated so heavily, but the roof wasn't in the report. At least it was not evident. And so now you have looked at it. I would just want to kind of एक question है, उसके बाद probably if based on your answer I'll probably, is your building, have you designed the building to be fully air conditioned? Have you designed your building to be fully air conditioned? वो चीज है, मतलब 24/7 वो air conditioning चलेगी नहीं ना? Now when you're talking about if it is basically, it's a mixed mode building, when you need it, air conditioning will be on, and when you don't need it, it will be off, right? In that case, you have to be very careful about how much insulation you are putting on the wall, on the roof is fine, because roof, especially in a place like Jaipur, you have the sun beating on it throughout, and the top floor becomes very very difficult to live in. Wall में it is important, because what will happen is that during the day you have reduced the heat speed of reduce the heat transfer from coming in. आपने AAC लगाया, then you have also put an insulation. AAC, the 200 mm thick AAC already will give you a U value of something like 0.7. ठीक है, आप 12 mm और लगा दोगे, which is additional, I think it will come down to say 0.6, 0.5, things like that. Now what happens is that you still have people living inside the house, right? So what will happen? And forget about the summertime. In the mid, like March ho gaya, October ho gaya, things like that, the outside heat, yes, it is reduced during the day from coming in, but still some amount comes in, and you have heat that is generated by the people inside, equipment inside, and all of that. If you super insulate your wall and you're not careful about opening your windows at the right time and your wind speed is not right, all that heat is going to be trapped inside, because at an insulated wall head, that means it won't allow heat from outside to come in. Yes, it won't allow heat from inside also to go out. Na? Is that thing. So you have to be very careful about how much insulation you're putting in a place. Like if it is completely air conditioned building will be fully sealed, right? You are controlling your environment like very strongly, then it might still work. But in a naturally ventilated building or a mixed mode building, you need to be careful about how much insulation is the right insulation. Okay, so the thought is good, but you need to be very careful about how much insulation, because don't think of insulation to be like sab kuch theek kar diya. Nahi, there has to be a balance in everything that you do. So that is my only comment regarding like specific comment. Otherwise, like, great work in in stepping up beyond what has been given in the report itself.
Thank you so much, Saswati, and a very big thank you to everyone who's come here to present today from the team. I'm going to now be announcing a very long lunch break, and we were very well in time. Well, thanks, jury, for helping out with that. So luckily, yes, we've earned ourselves an hour and a half. I'm going to request the next team, that is going to be accidental engineers, and the jury members to please come backstage at 2:20 sharp, so that we can quickly check the AV, everything again, and we can start exactly on time. That is at 2:30. Right? So thank you,
We
everyone, once again.
can we just
Yeah.
put off the mic and cam and just be logged in? Is that okay?
Yeah. Yes, you can.
Sorry, I just remembered one more comment here. I don't know if you have if you guys have thought about evaporative cooling in this place. I know the water is a constraint, probably that may have been a this thing, but Jaipur is a prime place to use evaporative cooling. That could have been a low energy cooling. And what Shelley and Venkat were also talking about, you have this very nice punctured wall, which Shelley did mention that only natural ventilation hoga, so probably you may not be achieving those drop temperatures inside. If the outside air is 41, you are not going to get 26 inside just by the Venturi effect. That's not going to happen. Hawa Mahal mein hota tha, that's a different thing altogether, different time also. But this is not the case right now. So you could have thought of incorporating something with your water balance check karke during some parts of the year, because Jaipur does have a big dry period. So there.
All right.
That's
Thank
all.
you, Saraswati. Anything from the team? Any more clarifications you want to seek? Because we do have some time. Otherwise, we'll break for lunch. So Yashraj, Sanskar, Ankit, Akanksha, anything from you? Any of you?
No, I just want to thank you guys for the comments which you made. We'll surely take that in a design. We'll surely take it. Thank you.
Okay.
Perfect. So thank you, everyone. I think they definitely deserve a big round of applause before we get the team out and break. So again, I'll see the jury at 2:20 and the next team. Yes.
Yes.
Thank you so much.
Okay.
Thank you.
Bye.
Yeah.
Thank you.
Bye.
Thank you, ma'am.
So, hello everyone, and a very warm welcome back to the Single Family Housing Division. We are going to continue with our presentations now. So, I'm going to take this time to please welcome our fourth team, that is Team Accidental Engineers. Team, I request you to please turn on your cameras so we can all start seeing you. Shruti? Thank you. Another very quick clarification before I move forward. Your fourth member, Shivjeet, hasn't joined. Okay, I see him now. I'll add him to stream. Perfect. Hello, everyone. I hope you're all doing very well. So, Team Accidental Engineers has worked on the project called Samyukta, which is located in Navi Mumbai. Their project partner was Samyukta Cooperative Housing Society, and they were supported by Mr. Abhay Kabra as the project lead. So I'm going to do a very quick AV check with all of you. I'm going to take your names one by one. Please say hello by unmuting yourself. All right. I'll start with you, Shanto. Hi.
Hi, ma'am. Hello.
Just give me a second. Yes. Hi, Shruti.
Hello, I hope I'm audible.
Yes, you are. Thank you. Hi, Dhruv.
Hello, I can't see you, but I hope I'm audible.
Yes, you are. You can't see me, is it?
Because the presentation.
Oh, okay, okay. Yeah, I understand. Sorry. And hi, Shivjeet. How are you?
Hello. Yeah, I'm fine.
Very well. So I'm
And
going
I
to put
hope
up
I'm
your...
audible.
Yes, you are. Loud and clear. So, some very quick things you need to keep in mind. You are going to get 25 minutes to be presenting in front of our jury. Our jury is here listening to everything you have to be presenting. At 20 minutes, I'm going to give you a very small ring, like this should be your warning that you have only 5 minutes left. Was the ring clearly audible to all of you? If just
Yes.
one of you, okay,
Yes.
perfect.
Yes, ma'am.
And in case you don't stop within 25 minutes, I'm going to hop onto this screen and ask you to please wind it up, and we'll directly move on to the Q&A, which is another 15 minutes with all our jury members, right? So I hope all of you are ready. The stage is all yours. You can please begin.
Hi, Sandro. Please.
Yes. Good afternoon to all jury members, participants, and viewers. We are Team Accidental Engineers. Today we have with us our own team lead, Dhruv Kabra, Shruti, and Shivjit. So we are a multidisciplinary team across three colleges, from Father C. Rodriguez Institute of Technology, Terna College of Engineering, Dr. D.Y. Patil College of Architecture. We are students pursuing Bachelor in Mechanical, Bachelor in EXCC, and Bachelor in Architecture. So our project, we present to you Samyukta. Samyukta is a single-family housing redevelopment in Vashi. So our project partner is Samyukta Cooperative Housing Society Limited. The key individual who is involved is the secretary, Mr. Abhay Kabra, and Samyukta means conjoined. So as the name suggests, we accidental engineers aim to couple the traditional and environmentally integrated spaces dwellings that residents call home with the modern technology. Next slide. Vashi is a node in Navi Mumbai, Maharashtra, across the Thane Creek in the Arabian Sea, in the outskirts of the city of Mumbai. Vashi is a well-planned city. Our site is plot number 14 of sector 10. It The connectivity here is established through local trains, buses, auto rickshaws, and the approach roads are tarred and cemented. Our site area is 1740 meters square. Permissible FSI is 2. Permissible built-up area is 120 meters square. That is 10 houses of 120 meters square each. Permissible ground coverage is 120 meters square. Proposed and estimated build-up area is 240 meters square. As our plot is located, as our plot is located near to the mangrove forest, and our plot being surrounded by two water bodies, it is much cooler in our at our site. And considering the microclimate of the area, our team designed this. The humidity percentage is around 70%. Next. So here we will briefly explain the goals and strategies uh, of our project. First one is resilience. Resilience is to create disaster and pandemic resilient accommodation, which can withstand extreme climatic conditions. Like Vashi receives a high rainfall, so we have designed in such a way that it can combat extreme climatic conditions like double glazing windows, jali walls, chargers, etc. Affordability. Coming to affordability, it is easy to afford and cost-effective design. Although our project partners have not restricted us with this, but we have always been tried to be cost-effective while designing. So for that we have used local materials, cost effective of carbon negative building construction materials like hum blocks from our existing partners like Green Jams. Energy performance. Coming to energy performance, our team aims to create an energy efficient housing to minimize the total energy consumption using various effective techniques. Our energy performance index is around 17.3, 16.73 kilowatt hour per meter square per year. Innovation. To create a climate response, energy efficient design, and self sustainable building. By incorporating innovative technologies such as IoT, VRV, etc., for moving towards better and sustainable lifestyle. Water performance. To recharge the groundwater table and reduce water consumption and minimize the water discharge. We implement this by comprehensive. Okay, coming to sustainability. Sustainability is design promoting mental and physical fitness. Designed efficiently to create healthy and green spaces. So coming to architectural design, it our architectural design is easy to afford and cost effective design made up of reusable materials having low operational cost due to usage of sustainable resources. For this, we are using construction using available materials, creating balconies, voids, recreational spaces to create more interaction. Health and well-being. Our team aims to create energy efficient housing to minimize the design promoting mental and physical fitness. So the plantation of indigenous vegetation to counter pollutants like PM 2.5, which is a common pollutant in Navi Mumbai. And also we are close to a mangrove forest uh, in our area. Engineering and operations. For this, we have to design efficient HVAC system using suitable use case. So we have studied many case studies, and from there we have adopted VRV systems for HVAC. Effective use of microenvironment by means of natural ventilation and night flushing. Scalability and market potential. Market potential, capability and market potential to create flexible, self-sustaining design and adaptive venues. Use of various innovative technologies to use locally available materials to create modular design. So that's it for me. Now Shivjit will continue.
So the pre-design process began with framing objectives for the design and with the research of case studies and finding case studies. And in this process, we found that the most efficient structures are is the vernacular architecture of our country, which is which we found out to be the most self-sufficient and sustainable one. So taking inspiration from these structures, we jotted down our design strategies, and that is how we had a culmination of modern technologies with traditional wisdom. The most
Team, I believe there's been a small technical glitch on Shivjeet's end. So if one of you want to take over, please feel free to do that.
No, actually, he's the architect. Just a sec.
Yeah,
interior
don't worry, we
and
can give him a few
the
minutes.
outdoors, thus
Yeah.
thus assisting natural light and ventilation. A grid orientation of the entire layout and passive design strategies like a backyard for every unit.
Um, Shivjit, if you could turn off your video.
Backyard for every unit and a indoor lily pool which and these are how they maintain the microclimate of the internal spaces. Next slide. The site layout
Can you see
shows
it? Yeah.
yes, the site layout shows the grid formation of the entire plan, which is laid in grids. Now, this grid connects building. Since it is a load bearing structure, no- since this is a load bearing structure, the the excavation will happen along the grids, and thus the foundation laid, so that the entire site is not excavated. There is minimal excavation, and it becomes easier for construction. The other benefit of having a grid plan is it allows backyard for every unit. A central road and a recreational area, and which connects all the units and through which all the main services happen. If we see a brown paved stone unit behind in every backyard, now all the services of each unit is carried out through this pavement, and thus it makes it easier for maintenance as well as easier for all services to happen. Next slide. These are the views showing how it looks in 3D. Now, if you see, it is a G plus 3 structure with every unit having a car parking space, a backyard, and all living, dining, thus creating a buffer, and which also helps in creating liveliness in the space and a bond between the neighborhood. Next slide. These are the individual layouts of every floor. The ground floor having an entry, a car parking area, and a formal living space, along with the kitchen and the dining space. And through this, we enter into the backyard, all being in a grid format and all spaces connected through arches. Use of arches so that the load transmission happens easily in the structure, since it is a load bearing unit. The first floor having a informal living space and a pantry behind, and having two bedrooms. Now all the four rooms have individual balcony units. So is the next plan of the second floor. The second floor now has a small lily pool. Lily pool in an internal lily pool thus helps in maintain reducing the internal temperature, and which helps in which creates a microclimate that helps in reducing the internal temperature of the space. Apart from this, if you see, the ducts are covered with green walls. Green walls thus help in also help in refreshing the air and reducing the internal temperature. And the third main objective of this layout was use of bricks. Bricks in rat trap bond. Now, rat trap bond also helps in pro- providing heat insulation, and also reduces the amount of material required for the construction. The quantity of construction, if compared to a normal brick wall, is reduced by almost by 25% by using this type of bond for construction. Next slide. These are the internal views and the layouts showing representing the views, with every view having the if you see, the ground floor layout has the backyard place, backyard having a tulsi representing the traditional space, a seating unit, and a paved passage. A hard rock paved passage along with a green paved area, a semi paved green area. Semi paved so that all the during rainfall, the water falling on the surface does not go waste. The entire paved surface is connected by a French drain which collects the water and thus harvests the rainwater. And if you see the green wall along the balconies. These are the internal views. In the central view, you can next slide. The central view, you can see the lily pool and how it acts into the space, making it more lively, and at the same time helps in maintaining the temperature inside. These balconies creating a buffer between the thus creating a buffer and not allowing direct sunlight to enter into the space, and also help in reducing the glare. Thus, all the internal spaces remain lit, and at the same time, there is no glare or direct sunlight entering into the space, and it also helps in more natural ventilation and cross ventilation of in the entire layout. Next one.
Can you,
Next slide.
can you see it?
These are the elevations. In the elevations, you can see the use of brick as a material, the floor slabs being constructed in wood, and having an RCC band entirely. Wood and flooring in and kadapa tiles as a finishing material. Apart from this, you see the balconies, use of mangrove tiles in the balconies, and on the terrace, you see the solar panels that have been laid out. The sections give you a better understanding of how these spaces are connected, allowing natural light and air ventilation. Mhm. Next slide. These are the details, construction details of how the grids have been laid and how the foundation will be laid in the grids. So, having a grid layout, the excavation will happen along the grids. The a PCC layer will be laid on which 600 thick UCR brick stone wall will be casted, upon which the rat trap bond the brick wall begins 1 feet above the ground level, and then you see the detail A and detail B show.
In addition to that,
A grid along with easy the grid with spacious planning is.
just we go through again that
So by using
the Shishit,
local
your voice is
materials, we
gone.
have which helps
Just a quick go through of the plan. We have a large entrance.
which helps increase
Shivjit, we have a large entrance. Then this is the initial lobby area and the dining. Then you have the kitchen and the wash area. Behind is the backyard. For when you come up to the first floor, you have a large living area which is open, and that's the pantry and two bedrooms with their individual balconies. On the top floor, you have the master bedroom, which is open to view the lily pool and also the seating area of the master bedroom, two balconies, and the last bedroom. And these were the internal 3Ds. Um, and then we'll go on to the individual. So here, the walls are pretty standard. We have just used an extra kind of we are rather than using a red brick, we have also proposed using agrocrete as a carbon negative material. In addition, for the roof, we have preferred China mosaic. Then a pretty standard double glazing for when we are closing the windows and when we are using, say, in extreme heat conditions, or when we are really using the air conditioning system, then we can like double glazing will be helpful. So for the HVAC system, we have VRV or else for so we know that some people are receptive towards new changes, like towards changes, new solutions. So we for them we also have an option of using dehumidifiers and specifically solving the problem of latent heat in really coastal regions. And the renewable energy, so solar PV is really oversized, and um that we'll look at it. That we'll look in further detail in the coming slide. So we've really focused on daylighting and reduced glare. So we have considered 130, and we have considered a threshold 130 to 1300 lux, and we have certain pockets which are not in that limit, but most of the area we have covered to be daylight. Then moving towards the consumption and the solar PV, this is something that was there in our feedback, that we have really oversized our PV system. So that is something that we have almost done it deliberately. That we have a lot of area. So the argument was that why not use that area? The only drawback is going to be your initial upfront cost for setting up that PV plant. So that is something that we, as uh, a design, we wanted to propose to give it that much of investment and use net metering to good effect. And yeah, so we basically oversized it a little. And then you have we've split it by seasons and the consumption. Only in the peak summer we have used an air conditioning, otherwise it is pretty standard. And that's the consumption. And this was done in PV Syst. And by hour we have used the lighting and the different appliances that we are using. So for health and well-being, yes, the IMAC band was really of importance, I'd say. And in addition to that, the impact of the climate, because there were two water bodies within 500 meters and a kilometer within the site. So it is generally, according to the survey, user survey, and also by common sense, it is a little cooler than further beyond. Also, with the forest, the microenvironment in itself has a certain impact. In addition, already the outside temperature, as we can see through the IMAC band, is pretty comfortable throughout the year for the 90% of. But only in May is it going beyond to the 80% band, and it is generally on the higher side of the comfort band. For so we have used natural ventilation. So the major counter was PM 2.5. PM 10 was a little less, and that was like countered by green walls and a lot of greenery to act as a natural filter. In addition, the dehumidifier that we have proposed for certain receptive users, that can also act as a air purifier. Now, uh, for the
Sorry, Dhruv, your time is up. I'll have to stop you right here.
no problem.
So you're all done. Yes. But anyhow,
I'll,
I'm going to call in the jury now to take the questions and answers. I think there was some technical glitch because of which you lost some time at the beginning. But yeah, just give me a second.
yeah.
Perfect. So I think one of my jury member is Saswati. Can you please turn on your camera so we can start seeing
Yeah.
you? Perfect. Thank you. Same old order. Venkatesh, I'm going to start with you.
Okay. Yeah. Okay. Good job, team. You had a very consistent language of aesthetics. The use of exposed break was kind of nice, consistently taken through. Um, you took a number of innovation. I mean, number of smart tweaks, and you weaved it very nicely throughout your design. So while there was no standout innovation, a number of little things that added together to have a well thought out design. But a few things just catch my eye. Okay, one is you mentioned it's a load bearing structure for design, is it? Yeah, that
Yeah.
I mean, So that I find a little strange because people are just kind of moved away from it from various reasons of seismic stability and all those things. Plus, you also mentioned G+3, but I see only G+2, so I kind of guessed that it was just like a oversight, right? Because the
Yeah, that I'd say was a slip of tongue.
yeah, that's
It
fine.
should
That's
be
okay. That's okay. That's okay. Just want to make sure because we saw those plans. I really like the fact that every room had a balcony. There was place outside, so there was the potential for a lot of cross ventilation. The only thing that struck me very odd is your use of solar panels was like so on your face. If that could have been reduced and made a little more subtle, that would have been like really great because this kind of is too on your face kind of design for the solar panels. And also gray water recycling. You mentioned that it's the rock strata is genus out there. So I'm not sure how you are really looking at gray water out here for your water balance. If that is something that you can just touch upon quickly now, without taking too much time, that will be good on the gray water aspect.
Shruti, if you can take that.
Yeah, sure, sir. For the gray water treatment, chemical and biological treatment procedures can be used to treat the contamination level in this water. And gray water can be generated by the sources and is collected in a common subterranean tank. The primary function of this tank is to equalize peak flows or surges caused by bathing or bathtub draining operations so as to standardize the quality of grey water obtained.
Okay, but what are you doing with it? I mean, I didn't see a proper system by which you're saying how you're reusing it back or what that is. So that was one thing which I really wish you had worked upon a little more. The other thing that I had was um, on your costing, right? You have a very compelling design. I mean, like I said, your aesthetics was very appealing. I was not too sure about what your comparison with a baseline cost was because I didn't see a baseline cost in your submission. So that section looked quite weak to me. So if you can just touch upon that now for a second, that would also be nice. Yeah, can you just summarize it?
Shruti, are you taking that or should I?
Any one of you, just do it. That's fine.
Yeah, so the baseline actually was less than what we like with all the brickwork and the solar. One thing was that in the baseline estimate, we did not consider the capital cost for the solar PV, and then in the proposed design estimate, we added that too, and so in the baseline estimate, we were going a little less than what we were proposing, so that was kind of a contradiction, but yeah, that the
No,
proposed
just there's
design.
no harm in your baseline being lower than the proposed design, right? I mean, that's kind of understood. There's no problem with that. But I'm just
Uh-huh.
kind of looking at the percentages with so much more that you're doing for MEP.
Mhm.
The numbers look kind of imbalanced for the baseline and proposed design. So I hope going forward you're able to work on this, strengthen this section a lot because otherwise, for a very dense urban situation like in Navi Mumbai, to
Mhm.
actually have a pretty good solution. Strengthen the costing, strengthen the section on
Yeah.
water balance, and I think you guys have a really neat solution.
Okay. Thank you.
Thanks. Yeah,
Thank you,
I'm
Venkatesh.
done. Yeah. Okay.
Sorry, go ahead, please.
No, I'm done. You can hand it over to.
All right. Yeah, so I'm going to go on to Shady next.
Okay. So congratulations, team. One thing that I really liked about is that you have rightly mentioned the issue of latent loads in coastal cities. So I think it shows the level of maturity that you have taken the problem. of air conditioning. It's not just providing air conditioning, you're also talking about the real issue. And you've also tried to give dehumidification as one of the strategies. So that is good. Another thing was also you're saying that you have tried to refer to IMAC thermal comfort models. But again, the question is that you are referring to only the naturally ventilated model. So, I mean, the question is that if you are looking at your space at the air conditioned hours, then what is it like? What is the comfort band that you would look at? So maybe you can also take a step further and see how can you utilize the standards in a proper way. Then another question I had was the air conditioning. I think in the presentation you're saying it's only running for 3 hours. So can you explain that? I mean, when is it running, and why have you considered only 3 hours?
Actually, we were like air conditioning was purely optional, to so to say, because um, we like the site location and the microclimate renders the area with a very pleasant. Of course, right now it's kind of a little hot because of the heat wave kind of situation. But other than that, it's really pleasant over here. So we were really fortunate in that sense. And the air conditioning system is like an emergency system rather than a continuous human comfort system. And yeah, so I mean that is logic. Like it is pretty less that we really did not propose an air conditioning system that is running throughout the summer. It's just
Okay.
for people who are really feeling very hot or hot during some time or things like that.
Okay, okay. So I think this is the point maybe you can consider because see, the thermal preferences are very, I mean, they can be perceived in a very different way. Like you might feel comfortable, but others might not. So maybe one thing could be you can speak with the clients for whom you are designing. But again, at the same time, it's always good to consider that there could be some other people who might come to stay and they might have different thermal preferences, and because of which your air conditioning may run more than that. Because I think that's the usual scenario in how people are living nowadays. And as you also rightly mentioned about the heat wave and considering the resilience part into factor, I think that should be increased a bit because that also directly converts into your EPI number. Right now it is 16 point something, which I think is already very stringent right now. The value that you are showing is already on a very lower side. So, I mean, if you are considering to get into the net zero energy kind of approach, you have to consider the air conditioning usage appropriately. So that was one point. My second point was on the construction material. I can see that you've used agrocrete. So this as a material, again, there are some statements that it can actually reduce the construction cost by 50%. If you compare it with the bricks. So I think these kind of statements, I mean, they might have been taken from the marketing cut sheets or something, but I think it is good to kind of validate these kind of statements because they are directly taken from the manufacturers, and I mean it's good to see and compare how it actually fits in your own project. Because if I see the construction cost right now for the proposed case is higher than the base case, so if you are if so maybe you can fragment it further and see that where is this material actually helping you to reduce the cost. That was one thing.
Yeah.
And then the last point was the window to wall ratio is around 32% on the south side. So, why have you guys thought of using this number? I mean, have you derived it, or it's because of?
Those were majorly it was in the window behind the buffer space. So yeah, if we have here.
Now here, though the window to wall ratio is 32%, but the windows are
Hmm.
not directly exposed to the southern surface. The windows, there is a balcony which creates the buffer, and then
Mhm.
there is no direct light entering or direct glare entering into the space.
Is it
Yeah. So here we have the north.
okay?
Yeah.
Okay.
So it is the
Okay.
southeastern surface that. Hmm.
Okay. All right. All right.
Yeah.
Then it's okay because I mean, again, the window to wall ratio also need to be looked at if you are, I mean, from the design optimization point of view.
Yes.
Just a quick for the agrocrete part of it. That was again more for the carbon neutrality or the carbon negativity aspect of agrocrete rather than the cost bit of it.
Mm.
The partners are saying that it is costing less. That's kind of that needs to be validated, sure. But the major reason why we inculcated that into the design was for the carbon negative aspect of it, rather
Mm.
than the cost bit of it.
Right, but even for that property, if you see the embodied carbon, I think for
Mhm.
red bricks in the table they have mentioned close to 0.24, and for agrocrete it's minus zero point 0.2 or something. But the question is that you always try to see that from where are they taking these values. Right now, only for thermal conductivity, I think the value is taken from Terry. But from all other values are self-certified. So if a manufacturer is saying that it's self-certified, I mean, it will be good to talk to them and see from where are they getting these values, so that you're more confident on what you're reporting. I mean, just a point you can keep in mind,
Yeah,
but
yeah.
it will be good to
Yes.
talk to the manufacturers and see how are they coming up with these numbers. Yeah, but overall, I think good job. It was really good overall, design wise, and you've kept it simple, and you've also tried to uh, generate as much of solar energy as possible. But the first process should always be to optimize and reduce it first, and then you try to integrate the solar energy or any other renewable sources. Okay.
Thanks, Shelley. I'm going to interrupt here because we're a little over time. And I'm going to hand it over to Saswati now for her questions.
Yeah, I'll just again keep it simple. Two, three things. One in Vashi, because it's a warm, humid kind of a region. Uh, the kind of EPIs that you are saying that you are, it seems a little unlikely for me. However, cool. I mean, it may be possible, but I mean, it really needs to be backed up a lot with that. And plus, if you are using air conditioning, and in your report and somewhere here you had talked about dehumidifier. So if you're talking only dehumidifier, meaning that the temperatures are okay, but you need to just take out the moisture from the air, still might be possible. But if you are using air conditioning, the 16.73 is seems unlikely to me. I mean, it's not a I mean, it won't go say beyond 20, 30, something like that, but 16 is a little, it seems a little too optimistic, so to say. Maybe if we go into the details of your schedules and things, that uh, may we might find reasons for why it is that low. But it seems to me that it's a little uh, too optimistic. But if you are able to get that with the air conditioning and the cooling, then nothing like it, like if that is there. But again, I'm being a little conservative here. Second, the second point is about the solar. Just because you have the land doesn't mean, again, because the cost of the, when you're talking about cost to hell, that is there anyway. You'll have, I don't know how much extra cost in because of the extra solar that you're putting. At the same time, you'll also have to look at what do you do with that solar that you got, because then you have to put it back into, if you have net metering in your city, then it is great, fine, you can give it back to the city utilities. But what if it's not there? So I won't think that that's a precedence you should, that's something that you should go for, unless you know that you can share that energy with someone else in a very convenient way. That would be, because you also need to look at practicality of it, because you're also looking at scalability and marketability and things like that. So be a little careful about how much you are, you know suggesting what in certain in these kind of strategies that you present. I'd just like to commend the group on one small thing is that I think this is one group in which there are more engineers than there are architects. I think because in most of the other groups it is majorly architects, maybe one or two engineers in the end. So congratulating the team for that because the aesthetics were pretty good, in terms of how the planning was done and how the building looked and everything. So congratulations to the team for that.
Thank you very much. And the net metering aspect of it is a big yes for here. And
Okay.
for the
So
site.
that needs to be mentioned. That's the thing. You cannot keep half. You have to give the whole picture. Otherwise, it becomes okay. Why are they doing this?
Yeah.
So that's what.
And also we have a little bit of subsidies here for like there's different slabs, 3 kilowatt, 10 kilowatt, like there's different slabs and you have different subsidies and different net metering say limitations. There's also a threshold, so it was kept under that, but we tried to utilize the entire area, which is like not okay. Some for so we really did try to make it kind of user. So we have 10 houses. So from those 10 houses, certain users
Dhruv,
might
I'll
be.
Hi, I'm
Yeah,
sorry to
probably
interrupt you,
can.
Dhruv, but the timing we had for your team in totality is over. I'm going to run late on my remainder of the schedule. So you can get in touch with the jury at a personal level if there's any more help you seek from them.
Yeah.
Right? I hope all of you understand. So thank you very much. I think, jury, it's time to applaud the team and let them go and take a sigh of relief. Well, great job, guys. So
Best
just to
wishes.
make up, yeah, just to make up for the lost time, I'm going to start with the next team in 3 minutes instead of five. So, jury, please be ready this time. Thank you so much.
Preferred this design. So it's people in.
Welcome back, everyone. So, our fifth presentation now is going to be by a team called RV Innovative. They worked on a project called Rupana, which is situated in Ramnagar district in Karnataka. They had project partners as Between Lines, which was represented by architect Guru Prasanna. So, team, in the meanwhile, as we share your presentation, I hope someone shared it from the back end. Can one of you please share your screen? And then we'll add it to stream. However, very quick things on the back end. You guys are going to have 25 minutes to be presenting. The minute we reach the 20-minute mark, I'm going to make this sound. This is going to let you know that you have only 5 minutes left. And if at all we do reach 25 minutes, I'm going to jump in and stop you right then and there. Your presentation's being observed by a jury who will hop in at the 26th minute, and then the stage will be theirs for 15 minutes to have a little question and answer with you. So before we get into the presentation, I'd like to do a quick AV check with all of you. So one by one, I'm going to take your names. Please say hi so that I can ensure that you're all being heard loud and clear. So hello, Hrutika.
Hi, ma'am.
Yeah. Hi, Iromita. I'm sorry, please excuse my pronunciations.
Hi, ma'am. You're right.
Yeah. Hi, Aditi.
Hello.
Hi. And hi, Ishika. I can't hear you, Ishika. No, you're not audible at all. We can't hear you. I mean, I know you're trying to say something. No, you're not. Can you hear us clearly though? If you can you nod your head? Okay, but we can't hear you at all. So we'll give you a few seconds to try to figure it out. Otherwise, team, please take your call if you want your backup presenter instead, and we can add your backup presenter for you. Ishika, can you check your... Okay, she's, I think, trying to rejoin. She's there. Can you check if you've allowed access to your mic? Yeah. Yeah, I think we're running out of time to be on schedule. Do you want your backup presenter, or are the three of you enough to take it forward until she joins? Can one of you please confirm quickly? Aditi, Rutika, someone?
1 minute, ma'am. Just we're asking if she can connect again.
And is she supposed to be starting the presentation as well?
Yes, and she's supposed to be sharing it as well.
Okay. You're not, Ishika. Can I ask you to do one thing very quickly? It's okay, let's not panic. Go down to the settings that you see on the bottom of your screen. Let's check if you've allowed audio. Okay, I'll help you out here. So click on the settings button. Did you find it at the bottom corner of your screen? If you found that, please click on audio and try to see if you have enabled your microphone.
Hello, am I audible now?
Yes, perfect. Got that.
All right.
I'm putting your presentation, guys. Please start immediately. I'll just have it up. Okay, Ishika, I think you're yet to share your screen again because you left. We could see it earlier. Perfect.
Can you see my screen now?
Yes, yes, I can. The stage is all yours now. I'm starting the timer, so you have 25 minutes. Please begin.
Okay. Good day, everyone. We are Team RV Innovative. I'm Nishika, and I'll be introducing the project and its salient features with respect to architectural design and resilience. My fellow presenters, Aramita, Aditi, and Ritika, will take you along through other features of this design pertaining to energy, engineering, innovation, health and well being, water, and scalability and affordability, amongst others. We present to you Ropana, a net zero single family housing project. We partnered with Between Lines, an urban architectural and interior design firm founded by architect Guru Prasanna and architect Deepa Suryaprakash. The project is situated in Harohalli, Ramnagar district, Karnataka, which is 140 kilometers away from central Bangalore. It is quietly nestled between a coconut grove farm. The house is designed to have two occupants living there on a permanent basis and four adults along with four kids living there on an occasional basis. The brief emphasized on the house being a retreat away from the Bangalore city. Some special requirements by the client were as follows, with special emphasis on the wellness of the mind. Other requirements were for the house to have off grid sustainable resources and spatial integration of a chicken coop and cow shed into the landscape. The location had two sites, Site A and Site B. Site B was chosen due to its higher elevational points, which would make it more resilient to flooding, and also closer proximity to the main road, making Site B more accessible in terms of transport and commute. The initial form was developed with the help of a sun path diagram. This helped us evade the harsh light coming from northwest and bring in ample north light into the design. The next step was to stagger the walls, as this would help us with self-shading of the massing developed above, further reducing its dependency on mechanical ventilation. After that, the pre-design analysis of the wind movement, which was from northwest to southeast, helped us decide the optimal location of the courtyard. This led to the design having thinner floor plates. This further indicated the maximization of internal shading. The detailed plan emphasizes and demonstrates these points and how, along with passive design strategies, it was integrated and manifested in the final plan. Coming to the user experience and key circulation zones, the exploded view on the left talks about in detail about the variety of spaces we have tried to include. The ground floor comprises a living room, a courtyard, a kitchen, bathroom, utility, and storage room, along with a dining room. In terms of outdoor spaces, it has an outdoor patio and an outdoor workshop area where multiple yoga workshops could be conducted in adherence to the concept of wellness. The upper floor would house the more private areas such as the bedrooms and the bathrooms. It has two bedrooms with one attached washroom and one common washroom. It also has a multi-purpose room which can be used for recreation of mini workshops. There is a loft space meant for the kids to bunk in. The diagrams on the right talk about primary circulation and secondary circulation zones. Primary circulation being around the courtyard, since all the other spaces spill out along the periphery of the courtyard. The sections on the left talk about how stack effect helps with the cooling of spaces by letting warm air rise to the courtyard and the staircase and letting it exit through the higher level openings, thereby letting cool air seep through and ventilate the other spaces, reducing the overall energy load on the building. The living room is sunken into the ground by minus 1.12 meters to keep it cool, since it falls in the northwest region, which receives the most harsh light during the day, making it the most heated region in the design. Mean value of the temperature outside and inside decreases by sinking the ground plane, and fluctuations in temperature are lesser in comparison to a situation otherwise. Therefore, by sinking the plinth, we were able to cool it down considerably. To sum it up, the key characteristics of the design, which inculcate major passive design strategies, are plinth level differences, staggering the walls along northwest, functional spaces for wellness, groundwater recharge system, and thin floor plates for shading. Moving over to resilience. It became important to assess the potential risks to the design. Our assessment led us to analyzing that The seismic zone of the site is Zone 2, thus being least prone to earthquakes. During the months of June to October, the site is prone to flooding due to the increased rainfall. Due to the secluded location of the site, the users may also experience loneliness. There is a high density of mosquitoes in the region. The users may be prone to dengue. A few benefits of the location happen to be the availability of constant energy supply courtesy the municipality and availability of everyday essential items due to the close vicinity of the site to the market. A few interventions in the design, apart from the location on the site and the staggering of the form, happen to be installation of mosquito repellent plants, a solar energy system for energy, a biogas system to help with the disposal of renewable waste within site, which would also power some household electrical appliances amongst others. A gutter detail has also been added in the courtyard to prevent water from flooding the entrance. Ropana user interface would help the user keep a track of their consumptions and savings. Relying on evaporative cooling and reuse of coconut cores in the building envelope also make the design more eco-friendly and thermally resilient. Considering the yearly degradation of the solar panels, a total of 36,763.34 kilowatt hour of energy is produced over the course of 30 years of the building, and a total of rupees 3,29,950.98 can be gained if the energy is sent back to the grid. Coming to energy and water, there are three sources of energy generation: solar, biogas, and from the grid. When the solar and biogas system are running efficiently, there is no requirement of taking energy from the grid, but the option has been given to do so. Coming to water, there are three sources of water: rainwater harvesting, recycling, and wastewater management.
We now present to you the energy performance of the building. The energy performance was optimized under different parameters, starting off with the orientation. The building is oriented so as to ensure maximum daylight reception while reducing heat gain. The orientation also helps facilitate natural ventilation considering the predominant wind direction. The staggered form provide mutual shading that help in reducing heat in the building. The simulations for the same have been shown for the month of May. The building does not utilize HVAC systems for cooling, thereby reducing the energy consumption drastically. Moving on, the size of openings along with their orientation help with lighting up 80% of the place naturally. Energy efficient LED fixtures with dimmable controls were used in order to reduce energy consumption. In a comparison drawn between LED fixtures, CFL, and fluorescent tubes used, it can be understood that the energy consumption reduces by 48%. The usage of dimmable controls also reduces energy consumption by 30%. The building area method was used to arrive at a light power density of 4.417 watt per meter square for interiors and zero point 0.6 watt per meter square for the exteriors, conforming to IGBC guidelines. BEE 5-star rated equipments are used that has helped reduce the energy consumption by 12.47% in comparison to baseline scenario taken from NBC. We now move on to see the renewable energy sources that the building utilizes, namely solar and biogas. Two 3 kilowatt solar panels are utilized on the terrace over an area of 32 square meters that produces 9,260.2 kilowatt hour annually, thereby satisfying the energy requirements of the building, standing at 6,697.5 kilowatt hour and making the building net positive. The feasibility of these solar panels have been discussed under resilience. In addition to this, portable biogas has also been used that utilizes waste from kitchen, farm, and animal sheds. The cyanoid biogas unit is used to accommodate the seasonal fluctuations in the quantity of dry waste of 30 to 70% complementary. The portable biogas unit, therefore, serves three requirements: eliminating bio-waste from the site, energy production for standby apart from the solar modules, which in conjunction, if used with a converter, the production of fuel for traditional gas stove cooking systems in the kitchen. We get about 2,449 kilowatt hour per annum from this biogas plant. We now move on to see the EPI of the building. The building achieves an EPI of 22.171 with the aid of various strategies that the graph demonstrates and that has been discussed before. These are the electrical and plumbing layouts along with the working of renewable energy systems. Moving further, Lightweight filler slabs of 200 thick with earthen cups as filler materials have been used, which saves energy consuming concrete, which accounts to about 20% of the total cost. Composite slab of coconut husk or coir sandwiched between foam concrete panels of 100 thick have been used for roofing, which gives a U value of zero point 0.8. Eco-sensitivity of the project is realized by opting for local materials like porotherm clay blocks, which is procured from 8 kilometers from site, tree bark, coconut shell, and the coconut husk, which is procured from site, thereby reducing the carbon footprint.
As we dive into innovation, we aimed at coming up with innovative techniques with reusing the materials on the site, achieving a cooling effect with locally available materials, and better knowledge of different systems adapted. Evaporative cooling. This system works by a method of running down the terracotta tiles, which are already going to be sourced for the design, through water. Air later, when passes through the design, ends up cooling the space entirely. This system is applied as a wall in strategic points throughout the design to render spaces cool, especially during the hot summer. It can be switched on or off and operated on a need basis. When not in use, it acts as a partition wall, while the tiles, being of terracotta, absorb the moisture in the air. Coconut coir. The site has a large number of coconut trees whose resources can be reused for the building construction, especially for the building envelope to help achieve a total U value of zero point 0.5 for the structure. The procedure involves bags of coir being soaked and dried on site and later rammed into panels that can be fitted in the envelope section and sealed. Ropana User Interface is an app that tracks the user's building system, which includes the various energy, water, and waste systems. This flowchart explains the working of the app. An attempt was made to allow it for different typology of users for this app. At a community level, it generates and educates them about various kinds of equipments available. It can also be used by vendors to maintain and organize their schedules and alerts of any threats, and for a single homeowner to keep in check of their space, allowing them to personalize it as well. Keeping in the main idea of calmness in mind, the app also looks to enhance the immediate environment by playing mindspace sounds depending on the need of the hour. Health and well-being. Approaching the design from the perspective of the user, the main goal of this contest was to provide a comfortable duration in all the design and adjacent spaces. Adapting the thermal comfort based on the ISHRAE standards derived from the climate consultant software, it was found out that the thermal comfort was necessary by design intervention for 8,758 hours, with the indoor temperature to be at a range of 21 to 26 degrees Celsius. This model was compared with the IMAX standards. The neutral temperature for naturally ventilated building varies from 20.5 degrees to 28.5 degrees Celsius, with the observed outdoor range with 90% acceptability in the range of plus or minus 2.4 degrees Celsius of the neutral temperature. The figure 13.1 highlights the discomfort months March, April, May, and June. The psychometric chart gives us the data and strategies based on which our passive design methods could help achieve thermal comfort. The three main passive design strategies adapted are envelope section optimization, staggering shading of form, cooling and ventilation done in accordance to the season. Factors such as visual comfort, acoustics, and landscaping were also taken to ensure well-being in the space. The envelope section comprises of porotherm bricks vertically perforated that is strong enough to take the structural load and also has the needed U value. Ram coir insulation chosen due to the availability of it on site. Gypsum plaster and an air gap is provided to form the needed thermal lag. Wooden joists, low thermal capacitors that act as ties between the main layer and the facing. And the facing is terracotta panels that help render the space cool and they have the needed U value. Calculations were done manually as shown, and the U value came up to be 0.5, which is compliant with the ECBC standards as shown. Staggered form of shading was derived using the sun-path diagram to shade the overheated zone on the northwestern facade. The stagger provides to be useful as workable indoor zones were not subjected to direct solar radiation as shown in the simulation adjacent. Further cooling of the spaces was done by sinking the living room by 1.12 meters, which allowed to regulate the temperature by reducing the mean value. Cooling strategies. The windrows map was studied in the months of summer as well as winter to understand how the flow of indoor air would occur. Openings were given in accordance to this, and subsequent sizes were determined by the basic knowledge of stack effect and wind speed pressure relation.
CFD simulations were done in places such as the dining area, where large openings were present on the southern side and acted as an outlet for air ventilation. The loft openings were created along the perimeter of the loft above the workshop space, allowing for heat exchange of air, as shown in the section beside. The application of stack effect is also seen in the main stairwell section as hot air rises, causing a negative air pressure below. This is further cooled during certain months due to the passage under the tank. The court, which acts as a main ventilation channel for the wind, allowing the spaces around the court to be cooled by added a shading tree. Annual simulations were derived at different times of the year. The solar radiation simulations were taken to see where and when the overheated zones were present. An additional simulation was run during the peak summer month using Design Builder to see the indoor thermal and temperature and thermal comfort. As seen in the table, the operative temperature mean was 29 degrees Celsius, which is compliant with our IMAX standards. Due to the difference between outdoor and indoor spaces, transitional spaces were introduced, such as loft and decks, that prevented thermal shock and stress. Well-being in terms of acoustics was looked at, where studies show that the coconut coir inserted in the envelope section has a noise absorption criteria of 3.9 at high frequencies and increases with the vertically perforated porotherm brick backing. This system was placed around private spaces of the house, such as bedrooms and living rooms next to the workshop areas. Indoor air quality was done in accordance to NBC, as the bedroom shown here is 2.4 air changes per hour. The visual comfort was assessed through Climate Studio in compliance with the LEED ratings and ensured 87% quality views. The adjacent outdoor spaces were designed to allow the nature surrounding to be welcomed indoors. The landscape plan was done in accordance to the experience of the space as well as the functionality. The plants chosen either helped with the plantation on the site to provide for produce, the enhancement of indoor air quality using less water, and plants that were used for medicinal purposes and natural insecticides. The plan consisted of interactive softscape for all the users, a private garden to allow residential privacy, rainwater harvesting, semi-hardscaping for animals, and organic farming. Market potential analysis was done and scalability was done in terms of components, where certain aspects such as material, labor, and technology could be scaled in different economic groups. Other strategies such as incrementality, mass production, strategic use of the systems either could be scaled, replicated, or ensure a sustainable use. Mass production. This could be seen as an opportunity to use the material to the fullest potential, where the first project's envelope could be considered as a prototype for the future projects to be built faster in terms of transportation and construction, thereby reducing the overall cost of the project. Incrementality, introduced when we look at reducing the number of levels and limiting the project to the ground floor by making minimal changes in the plan. In this plan, the dining table is converted to a bedroom and the first floor level is not built, but the staircase is built for future incrementality. Strategic use of the system. As the built-up area of the project is comparatively less, following the concept of incrementality, the energy required has also reduced significantly. Hence, the number of systems such as PV, bioswale, and grey water systems required to meet the energy needs would be lesser. The overall impact is shown in the bottom right table.
Water performance. Site's water demand is fulfilled through two alternative sources of water: fresh water drawn from ground recharge tables, rainwater harvested system. The quantity of usage of water is optimized to 75 liters per capita per day as per BWSSB, that is Bangalore Water Supply Sewerage Board, from 135 liter per capita per day as per NBC norm to sustain practicality of state of water in Bangalore. Grey and black water are efficiently collected and drained out to prevent leakage, odor, and integrated health issues. A house dwelling unit's demand can be fulfilled through waste stored in underground tanks and treatment systems. During drought conditions, excess of water stored during monsoon seasons, especially during November, and setbacks to reduce dependence of BBMP water supply. The domestic water is pumped to overhead tank, which is pumped to various components to perform the household activities. The grey water collected from bathing, washing clothes and utensils, cleaning house, pumped down directly to the soak pit. The black water collected from toilets and others are pumped down to the septic tank. The treated water from dispersion tank is pumped back to the fixtures for the further use. Additional source of water that contribute to primary source or tertiary sources, pavements, setbacks, and berms. Groundwater recharge system, which performs similar function as that of harvesting system, where the rainwater collected from the rooftop, pavements, and setbacks are let into the tank, heavy particles settle down, and the wastewater is treated by further filtration, chemical disinfections, boiling, screening. Periphery treatment, rainwater harvesting system, bioswales in dry conditions, and underground water tank are used for satisfy the demands of the occupants. STP tank, sewage waste is let into the STP tank where solid waste is separated from the liquid. Inlet tank where three-stage segregation takes place between scum, sludge, and wastewater. The treated water is further let into the fixtures for further uses. Conscious choice of lifestyle, efficient water fixtures, and implementation of the net positive techniques have minimized the wastage of water. Affordability. The constant focus on the following various strategies have lowered the construction cost, but also the operational and the life cycle cost. In terms of energy and water performance, there are PV solar systems and grey water systems, even though the initial capital cost is higher, but the remarkable future gains. In terms of materiality, we have chosen vernacular material and local techniques. As a result, lower the transportation cost and use techniques like coconut coir for the envelope to optimize thermal comfort. The total cost of the project has come up to 64 lakhs, which is affordable by the higher income group. The cash flows as of shown in the diagram, where the proposed cash flow upon which the hardcore cash flow is initial investment, the life cycle cost, and the operational cost are the further running of the project.
Summing up all of the 10 contests, we have tried to provide the most optimal solutions for the challenges faced. This slide showcases the best features of each contest, starting from architectural design to scalability and affordability, making Ropina a net positive, wholesome solution for single family housing. Thank you.
Thank you so much, team. I'm really forced into saying it was an amazing presentation, and all of you were excellently prepared to be delivering it. So I think it's time to call upon our jurors and hear from them. And I think by now my jurors are trained enough to take up my role too. So Venkatesh, over to you.
Yeah. I think like Dhoni, I need to hand over to some Jadeja for starting next time. So, okay. I just want to congratulate you, your team. I mean, it's just like Kasha said, it's like brilliant. And because you are so good, I'm going to be difficult with you guys, right? Because we expect greater things from good people. I mean, you covered all aspects of things very well. The one thing that I really wish that you do, is like when you tick all the right boxes and you tick it so well with so much of thought and efficiency. I would have really wished that you also did a tearaway design completely that, which becomes like the signature for single family house in solar decathlon, right? Like Eiffel Tower is for Paris or something like that. I mean, I really wish you guys had a tearaway design somewhere in achieving really good solutions for every other aspect of the 10 competitions. You guys ended up being very conservative in my opinion with your design itself per se. I mean, the design works, right? There's no problem with it, but you really wish that you had some uh, Zaha Hadidic kind of a form or shape, something that would have like, next year, like have our team waving and say, hey, this is what we want you to do. Having said that, few questions. Your Ropna user interface, you're just showing us the UI for that, or is it something that some good hack has actually developed an application? I mean, is it like a demonstrable thing, or is it just like a wish list?
It could be demonstrable, but as of now, it's mostly the UI that we were concerned and the aspect of which the app could cover. So the app also helped, apart from just talking about the like the knowledge and like talking about the systems
No, I
used, it
understand.
could
So
also be used as.
it's UI now at the moment, right?
Yes, yes.
Okay. Then evaporative cooling. So you had that one slide which showed you using evaporative cooling with water to the tiles, and that was right in the middle of the house. How does that work? I mean,
Sir, the if you can go back to the slide, it's actually around the court. So due to the way that the wind blows through, the court acts as a place, a neutral place for the wind to blow through. So that's why
can
we put it
you?
in the center of the house, and it
Is
cools
it
the
Your
possible
screen
spaces
to?
around.
share,
Is
the
it
screen
possible
share
to
has
share
stopped.
that screen?
Can you,
Yeah.
yeah, can you please share your screen again so I can put it up? Perfect. Yeah, go ahead.
Yes, the slide with the evaporative cooling, it's
Yeah.
placed around the main court, as all the functions around the court is where like the living room and the dining room area
Yeah, I
is.
think
So
the next slide, which where you had the yellow thing marked in the
yeah,
plan.
yeah, yeah, yeah.
Yeah, that's the one,
Yeah.
right?
Yes, sir.
But what happens in the first floor? I mean, that's right on the in the room, right? Your two yellow ones.
In the first floor, sir, it actually, if you see the image towards the right on top, it acts as it's placed on the bedroom partition walls. So it's during the summer months that render these bedroom spaces cooler. But it's placed on the top. It's not as an entire system, but more of like the sill level of it is actually higher.
Okay, so I think a takeaway for you and your team is really build a prototype of this and see how it works. Because I mean, to me, this was the weakest link in your design, right? I mean, again, I'm just telling you this, right? I'm being critical because you guys have been so good in everything else. So, I mean, I'm just trying to push you beyond the 100% mark to make this reality and actually demonstrate it. That's good. And what is the terracotta tile in the wall sections that you're showing? You have your coconut infill insulation. So, what exactly is the terracotta tile? Is it the regular Mangalore tile or what is it?
No, sir. Those are terracotta panels that are sourced. So it's not Mangalore tiles, but I mean it's not the same shape and
Yeah.
size of the Mangalore tiles, but it's the same material used. The
Okay. So that,
terracotta panels are 600 into 1.2 meters
yeah. Okay. So
each.
that's again something which doesn't really resonate with me, right? I mean, it's fine. It works very well as design, but probably an option for that, right? Because this again is not a very commonly done. The constructability of this is actually quite a bit of a problem. So that's something that you guys might want to look at. So here again, congratulations, you've done a great job. I'm being difficult with you just because I think you can take brilliant to the next higher levels of excellence. Okay, so don't get too hassled by my criticism. Right? Congrats again.
Thank you, sir.
Thank you, Venkatesh. I'm going to move on to Shaili now.
Okay. So, guys, congratulations. I think I was quite impressed with your presentation. And I feel that you have handled it with a lot of maturity. That was also seen in all the sections that you have attempted. Even while going through your report, I had the same feeling that you guys have a very well coordinated team. I mean, all the sections, the kind of attention that you have given, and they don't seem fragmented at all. The information is also flowing very nicely. You have covered a lot of points with a lot of detail. So I think it is fantastic overall. But again, there are a few points that I had and a few questions on how you have actually, since you are deciding not to use an air conditioner. Again, considering that I know it's in the pretty much in the outskirts of Bangalore, and Bangalore already has a very good climate. But again, if I take into account the climate resilience, so that again becomes a question. Maybe in the coming times, we don't know how things would be 10, 15 years down the line. So you also have to be kind of ready for that. Another thing was also your design builder output results are showing the indoor operative temperature to be around 33 degrees. Now, that could be for one of the days. But again, that itself shows that it's probably not a comfortable temperature to be at. So if you are considering that to not provide HVAC at all. So maybe this is something that you might want to relook into. So, I mean, even your simulation results are telling the otherwise. So, I mean, you guys have thought about it, or what do you think of this?
During that simulation was taken during the peak summer month, where we thought that our evaporative cooling method could sort of bring it down. So instead of using air conditioning, our alternative was the evaporative cooling innovation.
Hmm. Okay, but I think the evap cooling was also not able to bring it down significantly. So you might also want to check that if whether that comes under the thermal comfort band, or for how many hours you will be able to achieve this level of comfort. I mean, I'm stating this as a step ahead, like if you want to further enhance your analysis. Right now, I think what you have provided is really good. But I think if you want to just step up and kind of strengthen your findings in a better way, so maybe that's something that you can look at. And also, I saw that you have compared it with IMAC, with ISHRAE, and also the ROPANA. There was some number. So I
Uh,
just wanted to know if, I mean, are you able to measure the temperatures using ROPANA interface right now?
no, this was the projected view. After running our own simulations, this is what the Ropina design came up with, where we compared it with the standard and a baseline scenario of the building.
Okay. Okay. And lastly, one of the things was that you are also stressing a lot about acoustics, wellness actually. And under that, I saw you also mentioning about acoustics, air quality. But the question is that again, if you are considering your the structure to be located close to the main road, so are you also considering, maybe since it is located very close to that, in the near future when the traffic would be much more, would that be able to hamper the wellness that you're trying to achieve inside the space? So, I mean, considering the relevance part also, I feel you can again take a step further and see how you will be able to achieve the adequate acoustic levels inside the space.
Yes, ma'am. Yeah, we have thought about it in terms of how the landscape could actually help in. If you could go to the slide with the landscape plan. Um, Yes, ma'am. So the way we have landscaped the space around actually has an adequate distance from the main road and has enough vegetation to act as a sound barrier in certain times when it increases. But other than that, the basic idea was to make sure that the private spaces were insulated, whereas the more public, like workshop areas, were semi-open.
Okay. Okay. And also you can, in terms of acoustics also, you can, kind of think of it a bit more in terms of providing adequate materials, because in terms of noise transmission that happens from the outside to inside, even that plays, I mean, the kind of windows that you're using, what kind of wall materials you have, even that has a big impact on the overall noise transmission. And the same thing goes for two adjacent rooms. If you have, let's say, living room versus bedroom, because considering the work from home scenario, now even the sound transmission across room also becomes important. So these are the factors that also you can take into account in terms of selecting materials, finishes, what should be the absorbance coefficient, so that there's not a lot of there should be more noise related comfort in this space. I mean, just an added on point, but I think great job, guys. I was really impressed looking at your work.
Thank you, ma'am.
Thank you, Shelley. I'm going to move on to Saswati now.
Yeah. So, as the other jury members also said, very good work. And I was especially impressed by how obviously you have practiced your presentation, how you're going to present. It was very seamless movement from one to the other. So, very good, communication in terms of how you have done it today. Um, uh, Overall things, I think both Venkatesh and Shelley have covered. I would want to point out a specific thing, which may be a mistake or a correction or something. So can you go to your slide which talks about energy performance, where you have all the numbers, the table of numbers? Not that one. Yeah. then the one after that, 40. Okay, so if I'm correct in what you have assumed, by the way, considering Bangalore's current climate, the fact that you have taken a decision that okay, HVAC is not necessary, that's prudent enough. But again, as Shally said, going forward, we may have to relook at things as the climate changes. Now, if you look at your last column here, you see all those numbers, they kind of add up to at the end 18.61 kilowatt, right? And then this is the number that you have used to calculate your EPI, right? So you have said 18.61 multiplied by 365 divided by the built up area. That cannot be done, because if you look at this, in each of the rows, for example, if I take the first column, fan, energy consumed 360. I assume what you have done is 60, which is the wattage of one fan, multiplied by the number of fans, which is 6, right? That gives you kilowatt, which is the power of all the fans. For the energy consumed, you have to multiply it further with the number of hours that you are using the fan for. Okay, so this, I'm assuming that things will change quite drastically here. I mean, it may go less also. So this is not the correct, this thing. It should be kilowatt hour. EPI is always kilowatt hour. Okay, so in a day, how many hours are you operating each of these? So if you have six fans, if you're operating say 12 hours, so that's 60, you have 360 multiplied by 12, that will give you a number. That is the watt hour of energy consumed. Then for each of the separate rows, that's what you have to do. So you need to correct this calculation to see the correct energy number. So the unit is not right here. That is one. One other thing, can you go to one of the I don't know which slide it was, where you're talking about the ventilation thing, the stack effect, this. Yes, this one. Can you please explain to me, like in the lower left, you said that there's the hot air rises through the staircase, and then it is cooled by the tank, water in the tank. How is it cooled by the water in the tank?
The tank is actually if you see in the section, it has these perforations over there.
Mm-hmm.
So the tank itself is of a material that actually it's an RCC material that renders the space cooler, but it's not actual water droplets that do come out. It's just by conduction that it would become cooler when it passes through.
Okay, now the thing is that unless you actually are misting the air with water, this is a little unlikely to happen. Okay, so your best bet, because the idea of the hot air rising here, that there is a shaft, this is staircase thing which is on the southwest, which will get hot. So the idea that the hot air can rise through that is a good idea, but it won't be cooled down to the extent that you are showing that it will get cooled down and again come down again. What possibly would be a better idea could be that if you can allow hot air to kind of escape through the staircase throughout. So you have, anyway, you're putting in the evaporative cooling thing in your courtyard, right? So, and evaporative cooling is a one-through system. So if you can design a system in a way in which you can ensure that there is an inflow of air going through that terracotta evaporative thing, then the hot air, then the cool air goes into the spaces, and then it escapes maybe through most of it escapes through the shaft, through this staircase thing where you have openings on top. Okay, that might be a more practical, workable solution. All right, rather than this most probably is not going to work. So those are my two things here.
Thank you so much. A big thank you to the team and the jury as well. I think team, you guys definitely.
And it was a majorly here there are all girls, but I know that the team also has boys, but majorly girls through and through. So
I'm glad you said that, Shashwati. I didn't want to say that, but you said it. Good.
I kind of checked, is it an all-girl team? But then good work.
Yeah.
Very
Yeah.
good work. So if we have a few minutes, I also wanted to ask the what's with the symbol that you guys have come up with? If you want to talk about it. Your team's symbol. I think it signifies something.
Yes, ma'am. So that's the team logo actually. So if you look at it from the front up, so it looks like it says RV, which is the college we're from. But if you turn it upside down, it looks like a single house with a person meditating in front of it, thus representing our calmness, our idea of wellness through love.
Okay. Good, you've paid attention to details.
Well, thank you once again. Jury, we're going to break for a very short coffee break. So that was supposed to be from 4 to 4:20, but I think it was worth all the seeping into our coffee breaks.
Yeah,
So
yeah.
I'm going to meet all of you here at 4:20. It's okay if the three of you want to join by 4:25. I'll be here at 4:20 and I'll organize the sixth team by then, so you can have another 5 minutes to make up for it.
Great, thanks.
All
Thank
right.
you.
Okay.
Thank you so much. See you soon.
Yeah.
Thank
Good
And
luck.
thank
Thank
you.
you.
you. Bye.
Best
Thank
of
you.
luck.
Bye. Welcome back, everyone. We are finally here for the last presentation for today. So this is going to be by Team ZED. They worked on a single family house which is located in Daud, district Pune from Maharashtra. I'm going to give a few seconds for the team to join us. Can all of you please turn on your cameras, and only then will we start seeing you on screen. Perfect. Before we jump to the next segment, I'm going to do a very quick AV check with all of you. So please unmute yourself and say hi as I take your names one by one. So first, I'm going to go with Arya. Hi, Arya.
Hello.
Hi. Thank you. Next, Shalaka. Hello.
Hello, ma'am.
Hi. Perfect. Next, Atharv.
Yeah, hello.
Hi. Great. And lastly, Anagha.
Hi.
Hi. Perfect. So all of you can be heard loud and clear. While we put up your presentation on screen, a few reminders for all of you. So you're going to get 25 minutes to be presenting now. At 20 minutes, you're going to hear me make a sound like this is going to be a warning that you have only 5 minutes left, so you can gear up to be so that you can wind up your presentation, basically. And if at all you do exceed 25 minutes, I'm going to step in and put a hard stop. So please bear with me there. After that, we'll be inviting our jury who are backstage and listening to the entire presentation, and you'll step into your Q&A round for the next 15 minutes. Right? So I believe everything is set. I'm going to put your presentation up on stream. Can you please go to the presentation mode in the screen
Yeah.
share? Perfect, thank you. Right. All right, guys, all the best. This stage is yours. I'm starting the timer now.
Good afternoon, everyone. We are Team Z from D.Y. Patil School of Architecture, Lohagaon, Pune. We are 7 people working on competition with faculty leader Professor Himanshu Manjrekar and faculty advisors Principal Shubda Chafekar ma'am and Head of Department Aparna Mehtaras ma'am. And today, myself Arya and team members Shalaka, Anagha and Athava are here to present our work. Our site is situated at Gopalwadi Daun Taluka, Pune district, Maharashtra. Latitude 18 degree 27 minutes north and longitude 17 degree 34 minutes east. Proposed building typology is single family housing. The project partner is Mr. Pawar and his associate Mr. Vishwag Machale from Machale Engineers. The client is an artist with 5 family members, the artist himself, his wife, his parents, and 12 years old son. The total site area is 295.2 square meters. Total carpet area is 241 square meters. Total built up area is 326 square meters. And total landscape area is 68.5 square meters. As per ECBC 2017, Down falls under the hot and dry climate zone, and the climate analysis has been done by using 3 tools: Climograph, Bioclimatic Chart, Mahoney Table. As per the findings from analysis, April is the hottest month of the year, with the highest temperature of 39 degrees Celsius and relative humidity 27%. December and January are the lowest temperature months. Total annual rainfall is about 803 millimeters. The prevailing wind is from the west side. From analysis, we need to focus on reducing heat gain and promoting heat loss strategies to be used for the same. For this, we have done courtyard planning, higher thermal mass, natural ventilation, night ventilation, and a heavy roof over 8-hour time lag. The site is situated in the plotted development consisting of 68 plots with different plot areas. We have visited the site to understand the site context and surrounding, which can help us to enhance the design proposal. Coming to the site, it has a green belt situated adjacent to the plot with 10 meters wide nala parallel to it on the northeast side. The plotted development has primary access from west side and the secondary access from east side. The proposed site has been 9-meter wide access road from east side. We have superimposed windrows and sun path diagram in the site to show the prevailing wind directions on the site from the west side and secondary wind from the northeast side, which would be beneficial. The soil is excessively drained, light textured and shallow. The site is surrounded by agricultural land within 5 to 7 kilometers radius area, which is very beneficial in keeping the air temperature low throughout the year. Collaboration of site analysis and climate analysis helped us to understand the site context and capabilities for designing the single family housing unit. We have considered the 10 contests which are given by Solar Decathlon India to make our presentation and give all the information in detail. Now I request Anagha to continue further.
Pre-design process studied occupancy pattern, human comfort, and climate. Thus, we have designed our proposal on the concept of interconnecting multifunctional spaces. The dynamics of the spaces were decided on the frequency of the use and importance of that particular space. The three tools of climate analysis helped us to decide our approach, that is to promote heat loss and reduce heat gain. With this approach, we could tackle the hot and dry climate of the Next slide. The zoning has been done according to the analysis of solar angles and wind direction. The space has been done according to the clients and project partners' requirements. We included the architectural and climatic factors while conceptualizing our design, like common areas, connectivity, privacy and inclusion, multifunctional spaces, orientation, form and space, comfort, and levels. Orientation of the building and placements of rooms helped us to reduce the heat gain. The solar radiation on northeast and east side is less compared to other sides, so the common area like living room, which is occupied mostly for the whole day, is placed. Also, there is a connected open court for visual comfort, which can act as a multifunctional space for living and dining. Kitchen is placed at southeast side as the occupancy here will be in the mornings and evenings to take the morning sun inside the building and avoid harsh sun at evening. Service block at west and southwest side to act as a buffer zone and help to reduce heat gain as solar radiations are harsh on these vertical surfaces. Studio at northwest side to take advantage of north light for full day and it can have direct access for the visitors. The semi-open space acts as an extended area for studio. This helped our concept of privacy and inclusion. First floor house houses children as well as owner's parents' bedroom with open terraces and sit-out area, whereas second floor has master bedroom and guest bedrooms with a sit-out area to create connectivity between the spaces. The daytime spaces are placed so that they are shaded for most of the time to achieve thermal comfort in summer months. The prevailing wind is from west side, which is taken inside from the staircase block and open terrace. It will help to reduce the air temperature in the house, and the double heighted areas will help to create air pressure. The warm air will move out from the north and south side openings in the dining area. It will act as an interactive space as well. Most of the functional areas are shaded in summer due to the built form provided thermal comfort. According to the research done, trees and other plants help to cool the environment, making vegetation simple and effective way to reduce heat. With the help of these kind of trees, surrounding air temperature can be brought down by 7 to 8 degrees. Now, I'll ask Shalaka to present water performance.
The less you
The less you use the water, the more you save the water. Water preservation is very important to prevent the future devastation. Water cycle diagram showing the process of water flow. There are two main sources of water. Primary source of water supply is down. It is through Khadakvasila Dam, Pune to overhead tank of Down Municipal Corporation. Later supplied to the well in Gopalwadi and then Gram Panchayat overhead tank. From the overhead tank to each household through pipeline. As per the MDC, total 135 litre of water required per person per day. It is divided according to the requirement per person. We have provided 10,000 litre water tank fire for 30. Total wastewater generated by flushing, bathing, laundry and dishwashing is 525 litre per day, in which grey water generation is 440 litre and 85 litre of black water as per the calculations. Hence, 440 litre, that is per housing unit, grey water will be treated into the grid waste system provided on the east side of the site. The capacity of the proposed grid waste system is 3 MLP, which is catered to all the plots. Considering the 10% of wastage, for 1 hectare liter of treated water will be reused for flushing, gardening and car washing. Remaining water will go to the sewerage. The secondary source of water is rainwater. The rainwater collected through the three type of surface areas, that is rooftop, impervious and the pervious areas. Collected water will be filtered from the filtration tank provided on the site and the filtration water will be collected in the storage tank of 13 cubic meter capacity. This collected water will be reused for irrigation, landscape and groundwater repair through borewell. Calculations have done for rainwater and the wastewater. Total rainwater of the 2020 in Gopalwadi is 160 liter as per the IMD records. Considering the impervious areas from the site and the runoff factor, the total 12,000 liter water is generated. This will be stored in 13 cubic meter storage tank. Total 625 liter plus water is generated considering the occupancy of 5 people, in which 85% of grey water and 15% of black water. For reduction in water consumption, low flow fixtures are used. Therefore, we achieved a water saving of 30% as compared to the base case. Moving to the energy. Energy conservation is the effort made to reduce the consumption of energy by less use of energy services. We have used different strategies to minimize energy consumption. The first strategy is the window fenestration. We have provided double glazed 6 glass with air cavity. SSGC is of the glass is 0.61, VLT is 71%, and the U value is 1.8 watt per square meter K. The second strategy is shading devices. 0.5 meter wide overhang and triangular side hinge provided for each window to minimize direct solar radiation through glass. We have achieved a 15% of window to wall ratio. The third strategy is solar hot water system. As per NBC, we required 25 liter hot water per person per day. Hence, 125 liter capacity of hot water system is provided for 5 people. The fourth strategy is thermal mass. Composite wall assembly has been designed to reduce the heat gain in hot and dry climate. We have achieved of U value 0.38 watt per square meter K by providing AC blocks, fly ash bricks, 10 air gap in between the AC blocks and the fly ash bricks, and the Vedic plaster provided on the both sides. The next strategy is composite roof. U value achieved for the roof is 0.39 watts per square meter K. Composite roof helps to reduce solar heat gain through different layer of roofing materials such as MS beam, purlin, metal deck sheet with concrete and waterproofing layer. The last and the most important strategy is the renewable energy. Energy consumption throughout the year is 11,400 kilowatt hour per year. As per the market survey, we have proposed a hybrid solar PV system. The capacity of the system is 10 kilowatt hour. Required area for the installation is 60 square meter. Average generation is 40 unit per day. Hence, energy generation through hybrid system is 14,400 kilowatt per year. On this system, we can run 16 number of LED lights, 4 number of fans, 3 number of 2-ton AC, 1 fridge, washing machine, and microwave oven. Extra electricity generation is 20%, that is 2,800 kilowatt per year, which will be given on the grid system. Then daylighting is to use windows and a skylight to bring sunlight into our home. Hence, we need to design proper shading device and use of low glass. With the help of low SCGC glass and the shading devices, we have achieved the 59% of daylight factor. The daylight simulation achieved through the design builder software. The graph shows the base case energy consumption of 20 kilowatt hour per square meter. It has been given by Solar Decathlon in an EPI challenge for single family housing unit. In the proposed case, we have achieved energy consumption of 3.77 kilowatt hour per square meter through the proposed hybrid solar PV system. The second graph showing the monthly energy consumption of proposed case through equipment, lighting, cooling, pump, and fan. Therefore, total consumption is 11,400 kilowatt hour per year. So base case EPI is 70 kilowatt hour per square meter per year. Then target EPI is 39 kilowatt hour per square meter per year, and we have achieved EPI of 35.69 kilowatt hour per square per year through the different strategies. So I will hand over the presentation to Atharva.
Oh, the most important part was affordability for pitching the client. For this, we used five strategies. First was the choosing the building technique. We chose a steel frame structure for the building framing instead of conventional RCC frame structure, and a deck sheet slab for the floor instead of RCC slab. This will help in reducing the quantity and the material like cement and reinforcement, which requires the most of the cost of the building. Second was proper project planning. This will help us to understand the types of work that can be done simultaneously and which work will require how much time approximately. This prior planning will help to reduce the obstacles in the future and will help in the speeding up the overall process. Third was reducing the labor cost. As we inculcated steel frame structure, this can be erected in a less amount of time. For this type of structure, we also require very less time for curing. So the number of daily wages for the staff and the workers is overall reduced, and so the labor cost. Fourth was using local materials. While deciding on the techniques, we did nearby market survey for the site, and we found that the manufacturers themselves in the Kurkum MIDC area, which is around 12 kilometers from the site. This helped us in finalizing the construction techniques and also the reduced transportation cost and overall carbon footprint of the building. Fifth was using B rated electrical equipments and renewable energy. Using 5-star rated electrical equipments helped in reducing energy consumptions, and additional use of solar PV panels supported generating the electricity and making the building net zero energy. And this will also help the owner to create a passive income out of it after some time. Coming back to costing, the structural cost will be less in the proposed case as compared to the base case. Uh, the labor cost was again reduced to in the proposed case with the help of steel frame structure, as it takes less time than the RCC frame structure. The equipment of MEP costing was increased due to the use of 5-star rated electrical equipment, low flow fixtures, and installation of solar PV panels. But the overall cost of the proposed case will be less, and we will be able to save up to 5% compared to the base case costing. The payback period for the solar panels will be around 3.5 years, and after that onwards, the owner will be uh, have a passive income from the same. I would request Anagar to explain more about innovation.
The major concerns or problems zeroed down after the discussion with the project partner are affordability for the stakeholders, thermal comfort, and environmental impact. To cater to the above listed problems, we are proposing steel and concrete composite structure. In a city like Dam, there is an increasing demand of affordable housing. The affordability factor is important for all the stakeholders. In a conventional RCC structure, there is a significant environmental impact due to the extensive use of cement, sand, and water. Also, there is a rise in cost sharing during the construction periods due to the labors and materials. The proposal of steel and concrete composite structure will have a substantial reduction in the material and manpower uses as well as the cost required for both. And from our case studies, we found out that it will help to reduce the water consumption by approximately 40%. The second innovation we were proposing is Vedic plaster. It's a gypsum-based cloud and plaster which insulate building. The use of Vedic plaster to save electricity and environment and help to protect our climate. As per the experiments carried out by our industry partner, owner of Vedic plaster, Mr. Malik, Vedic plaster has low density and thermal conductivity that saves 24% of operational energy as compared to the conventional cement plaster. In addition, it eliminates the use of sand and it saves water and energy as it does not require curing. This will benefit the project partner monetarily as the expenses on water will be reduced. The use of Vedic plaster enhances the energy efficiency of building than the conventional plaster. The observed difference between the external and internal temperatures is approximately 8 to 10 degrees Celsius as per the experiments. The occupants will get benefits in operation and maintenance cost as energy bills will be less due to limited or no use of HVAC. Our proposal of Vedic plaster and steel concrete composite structure will make a remarkable impact in the market as it can be easily implemented and made from the easily available local materials in market. The project partner as well as the target customers will benefit from the proposal in terms of cost, resources, and energy savings. The next contest is scalability and market potential. The single family housing unit is based on passive design, sustainable materials, and technology which can be replicable in hot and dry climate zones. The solution is scalable in terms of cost as well. It can be replicable as a cost effective prototype in terms of energy and resource savings. The architectural design is also based on the concept of interconnecting and multifunctional spaces, which, with certain modifications suitable to the site and client's requirements, can also be replicated. On micro level, the solution can be repeated in the other 67 plots in the campus in terms of building techniques, which will result in faster construction. The basic needs of the target market has been identified after the site visits, numerous discussions with the project partner, and analyzing the data collected. With the help of analysis, market segmentation has been done on the basis of demographics, geographic, and socioeconomic. The requirements of the target market has been shortlisted, and those are incorporated in the architectural design. The factors which have been considered to analyze the market potential of the proposal are potential customer base, competition, and profitability. The proposal of steel and uh, sorry, the potential customer base has been identified middle income group, which constitutes the working class and farmers. Many residential developments are coming up and down with similar scale and similar customer base as per our project partner's proposal. The innovation proposal of steel and concrete composite structure brings down the construction time up to 1 year compared to conventional RCC structure. The whole project can be constructed in lesser time, can fetch faster returns on investment, proving profitable for the stakeholders. It can save cost up to 50% due to the time saved in construction. With the help of the project partner, can keep the project cost affordable, which comes to 5% less than the conventional construction. The target market, the project is also profitable as the project completely runs on the solar power with extra energy generation, which can transfer on grid. The payback period is 3.5 years for the system. Our strategies to conserve water can save 30% of potable water. Overall, the operation and maintenance cost is 6% less than the conventional structure. When the two projects of similar scales are compared, a project with a net zero approach will have weightage and generate more interest in the building. I'll now ask Arya to take us further.
When it comes to health of family or residents, it is necessary to invite thermal comfort and ample amount of daylight ventilation to the structure. For this, we have considered the landform, vegetation pattern, street widths, and orientation. The other thing which we considered was fenestration details, roof material, and the wall material, which is before explained in energy performance. Coming to resilience, the down falls under the zone 3. For resilience, we have considered earthquake, heat waves, and flooding. For In this plan, we have explained what the strategies which we have applied in the for resilience factors. The plan shows various facilities provided in the bungalow to withstand the resilient factors. Fire hazards, rooftop photovoltaic, and elevated planes are provided for the resilient factors. Now I request Atharva to explain engineering and operation.
For our project, we are using steel structure instead of RCC. Steel is like an endlessly recyclable, fire resistant, earthquake resistant, and has lesser impact on the environment. Steel structures offer flexibility, larger spans, and precision, and can be erected with minimum labor. This is the plinth level structure plan, and its reference will be used to explain the further details. Steel column and foundation detail. Raft foundation with plumb concrete on periphery external walls will be done. RCC columns of 450 to 450 by 450 mm will be beneath the steel columns and will be constructed. For the steel column to fix the RCC columns, firstly grout layer will be made and the base plate will be fixed on it by the nut bolting. Steel column 200 by 200 will be welded to the base plate. Typical column beam joinery. Column beam will be connected with the MS cleat angle. For the slab details, the first beam will be placed followed by the purlins, then the deck sheet with the concrete of 120 mm thick. On the second floor slab, it will be covered with the waterproofing agent. Wall column joinery. Angle cleat will be welded to the column and for the wall joined with the chemical bond. Now about the final point, that is the waste. Waste management includes the process and the actions required to manage the waste from its inception to the final disposal. Proper management of waste is important for building sustainable and livable cities. In our project of single housing planning, we will be incorporating three different dustbins for a single or single dustbin with 2 3 compartments. First is the green waste, in which it will include the kitchen and the garden waste, and will be either used for the converting it into the fertilizers. Second will be the blue waste or the dry waste, and it will majorly include the dry paper, cloth, wire, etc. And the third one will be the red waste, which will include hazardous materials like tube lights, batteries, cleaning agents, paints, medicine, e-waste, etc. Now I will request Arya to conclude our presentation.
The whole project is an integrated effort The whole project is an integrated effort to enhance the user comfort, create awareness, and achieve the goal of affordable and net zero building. We are thankful to Solar Decathlon for providing such a platform and opportunity wherein we can start our journey towards thinking and implementing net zero development. Thank you.
Thank you so much, Team Z. You were definitely within time, and that was a very exciting presentation. So, are you ready to take on some questions from the jury now?
Yes.
Okay,
Yes.
perfect.
Yes.
I'm going to invite my jury members. Do we have Shelly here as well? Okay, perfect. So, Venkatesh, you know the drill.
Yep. Okay. As usual, good job, team. You again comprehensively covered all aspects of what needed to be done. Atharva, just one small observation. Steel by itself is not fire resistant. Steel is really terrible in case of a fire, but accidentally you got the detail correct. So you protected it well against fire. So your building will still be extremely fire safe, but not by just having naked steel. But your detailing there was spot on. And I like the fact that you're thinking of, steel for your earthquake resilience. Water balance was also fine. Power was also fine. But I just wonder whether there was just way too much windows out here, considering that this is in Dawn and in Pune, where it's kind of actually predominantly a little hot kind of a place. It's not like a cold place. It's like hot, dry. And I just wonder whether you had way too much windows out there, and that necessitated that shading of the window by pulling out the window protection. I just kind of wonder whether, given the kind of construction you had, you could have just tucked it in inside rather than having it projecting out, because your detailing for the other areas with the facade fenestration was very, very nice. Um, just again, a design observation. The space about the puja room was something which I didn't understand. Can you just take a second and explain that to me? Because that again seemed to be tucked between two towers. Was there something happening above it, or was it open all along?
Sir, actually, the puja room was placed inside the courtyard because of the client's requirements. They wanted to have a secluded space because they are quite with the puja and all, they are much into it, and they wanted a secluded space where they could have a gathering without disturbing the house area. And it is not a double-headed space. It is covered, the puja room is covered. The
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 puja
small
room.
section is covered.
Yeah,
Do
the
you
puja
want the
room.
presentation, Venkatesh?
Yeah, can you just open that for a second?
Yeah. Can you please share your screen again, and I'll put it up for
And
the
yeah,
jury?
just show the plan.
Yes, sir. Just a minute. Arya, can you
Whoever
please
was
share?
sharing the screen would
While
have to.
Yes.
while you're opening it and waiting for it, just again a point on your schedule. I mean, you guys did your costing thing quite nicely, but I don't know why you had to take payback over 3 years for construction costing to happen. So a project like this should happen in like probably 6, 8 or 9 months, right? But I noticed that your costing had spread over 3 years. I don't know. That's something that we need to see, right? I mean, no one is going to want to wait.
Uh, Sir, the payback period is considered for the solar renewable panels
Oh,
and not for the building. And yes, of course, the building will be completed in within a year.
yeah. Because you talk about it and you're talking about scheduling and all that, which is kind of really nice, because you're one of the few teams that actually spoke about that in a very specific way. Yeah, that's nice. Okay, so just explain the. So you have the small puja room out here, but is it covered on top? Because it looks like it's in the middle of a green courtyard. So I'm just kind of wondering how that happens.
So yes, it is covered on the top. Arya, can you please show on the next this the adjacent one? Yes. So it is covered on the top, and it is not going above the first floor. So the puja room itself will be covered, and the courtyard is also semi open thing.
Okay, fine. Now I understand. Okay, I didn't catch it in this section.
Okay.
Okay,
So in the section also we have shown it. Sir.
okay, fine. Thanks. I'm done with my observations.
Shelly, over to you now.
Again, good job. I think you have detailed out a lot of.
Shelly, you're not very audible. Can you please go closer to the
Is
mic?
it better?
Yes, it is now. Perfect.
Okay. So yeah, I was saying that you've done a good job, team. I think you have detailed out a lot of sections very well. And also you have provided some unique. You're also talking about providing this Vedic plaster, which I feel that it's a very different concept that you're bringing in, and also there is some comparison that has been done with the conventional cement plaster, and I'm sure it must be better also because it's using more sustainable materials. You have a lot of data from the manufacturer, but it would be good to kind of check from where are those values coming from. One more thing that you can also add is with respect to its carbon emissions or embodied energy. I'm sure it would be much lower in case of Vedic plaster, so that can also help you to understand how your structure is performing in terms of sustainability. However, I also noticed that this material is very efficient in terms of its spread, in terms of also cost. So that is one added advantage, that it has good thermal properties, as well as it's also cheaper in terms of its cost. But probably you can also check it in terms of its hygrothermal performances, how it will perform in terms of moisture transfer, whether there could be any condensation or mold growth related issues. I mean, depending on the climate, you need to understand whether in terms of if you want to scale it up and use it in different type of climates, would it be feasible. So that is one of the suggestions. um, then in terms of the cost, I can see that you have compared proposed case and base case very well. So I think it's a good way to represent. You have also created sections like landscape, equipment, MEP, internal works, and civil works. I think it's a good way to represent. It provides a fair idea. But here, I think in terms of equipment and furnishing, I can see that your proposed case is higher than the base case. So, I mean, is there any specific reason for that? I think it's more than 2 times.
Yes, actually, we have proposed like 10 kilowatt of solar PV panels, and we have included that into the equipments. So it
Okay,
has
okay.
increased cost.
Okay, okay. And the same thing goes for the civil work. I can see that the proposed case is almost half or probably 40% less. So is it because of, I mean, what is the main thing contributing to this?
Main thing will be the labor costs, because the labor costs, it is based on like daily wages, and we are
Mm.
completing like in less than half of the time of the conventional RCC structure. So it will also help. And yes, the cement is actually the most important part, which was increasing the cost, because it has to be transported from away from the site.
Mm-hmm.
Yeah.
Okay. Okay, I think this is it from my side.
Thank you, Shelly. Over to you, Saswati, now.
Yeah, I was just looking back at what my earlier comments in the report were, because overall, I think design works well, and you have taken into consideration some of the comments in terms of, in the report there was no mention of what the shading is doing and everything. I could see shading and all of that in your design. Just I think I missed somewhere. You said 10 kilowatt is the solar that you are putting in, right? How much is the generation in a year from that? Have you mentioned it somewhere in the presentation? How much is it?
Yes,
Can you
ma'am.
just, how much is it?
Yes, ma'am. It is the 14,400 kilowatt hour per year. Yeah.
Okay, so that is another correction I think from the report that you have done, because in the report there were some other numbers there which was not making your design net zero at all. So I think that is something, the fact that you have again added on to what was there in the report. Another thing that I saw, I mean, I thought probably, and I think that would be a question to you in the sense that because it's hot dry, so as a low energy cooling system, again, evaporative cooling could have been thought about. But I don't know if there were any constraints in terms of using it and why you didn't go for it at all. So, I mean, you may or may not want to answer it right now, but that is something that. Um, that maybe you can keep in mind. Probably if you also think about it in conjunction with your water balance and the water design, so that would be something to uh, think about. So yeah, that's all from my side.
Thank you so much. Any questions from the team? Anything you want to ask the jurors from your perspective? Because we have a few minutes in hand. Otherwise, I'm going to wrap up.
Ma'am, I would like to answer to Saraswati ma'am's question, like about the evaporative cooling thing. Actually, the thing is, our site is situated amongst the agricultural land and around 5 to 6 kilometers radius. So, the overall air temperature around our site is quite less compared to the like if considering hot and dry climate. So we are considering that the air which is coming from the west side, which have agricultural land around, so it will be less heated than expected. So that was the concern.
Yeah, but in that case, I could also do that. And why have air conditioners too? You know, in the sense that there's a stepped up kind of a thing, right? That,
yes.
For example, I can give you an example right now. I'm in Delhi right now. My cooler is running because it's hot and dry right now. And then, as in when I will go get into July, then my air conditioners that's when I will use. So, I mean, if you have water available, or if you can reuse water, I think that would be a good way to look into it.
Yes.
And I do
Yes.
know that Pune itself uses a lot of evaporative cooling and all of that within Pune itself. So this is much drier, I would say, this place that you are designing in, right? So that's one way to look at it. And it's a single family home, so you can probably design ducts and stuff like that too.
Yes, ma'am. Actually, it's in a plotted development, so we also have little restrictions around it. So still, we will try
think
to.
about it.
Yes,
That's
yes,
as
sure.
architects, that's the whole thing
Yes,
of
ma'am.
finding out the solution, right?
Definitely, we'll think about your suggestion.
Perfect. Thank you so much, Team Z, and thank you to the jurors for a perfect Q&A session. I think this definitely calls for a round of applause. So thank you very much. I'm going to put the team off the stream while my jurors remain here and we can end the session.
Okay, best
Thank you so
wishes,
much.
Team Z.
Thank you so much.
All the
Best wishes
best.
to you all. Thank you so much.
Thank you, jurors.
Thank you so
for
much.
your kind words. Thank you.
Thank you so much.
So, well, surprisingly, we all look very fresh even now after a very long day. This
So
brings
the
us.
first team after the lunch was a little difficult,
Yeah.
but after that it was okay.
So, folks, well, thank you so much. That brings us to the end of our division for the single family housing. I have a very esteemed panel with me, and they've shown immense dedication throughout in this entire process of corrections, comments, and all the back and forth that we've done. So, a very big thank you to all of you, really from me and the entire SDI team out here. As the jury coordinator for this division, I've had the opportunity to see all these teams submit deliverable 1, 2, 3, etc. Towards the earlier times, I was also involved in marking a few of them. And I think they've all done an incredible job. That is something we cannot negate. So we can't forget all these teams, how they've discovered to collaborate. They've learned teamwork. They've learned so many soft skills. I mean, I'm just talking about things other than the technical expertise that they've gained from these rigorous 8 months. And that is definitely worth acknowledging. And that was the entire vision of Solar Decathlon. So, when we see all of that coming together today, this evening, jury members, you have a tough decision in your hands. You have to come up with a winner for this division. And I'm sure we have, how many can I say? Too many butterflies crawling. So you have quite a lot in your hands. I'm going to come back to you for that. I'm going to request everyone who's viewing our live stream to please take a few minutes, go back to the lobby, and you can see our exhibits there. It's also going to allow you to look at how other divisions have performed, what other submissions we received, etc. So you'll get the essence of what happened throughout the day. Meanwhile, I'll also like to request all of you to please submit your votes for the People's Choice Movie Awards. Lastly, you can all also feel free to go back to the lobby and hang out, because we'll have our jury members joining in on the lobby networking session soon. So you can all interact with them and ask any further questions that you have in mind. Last but not the least, everyone, please have a very great evening. And I'm going to wait to see all of you at 10 a.m. tomorrow for the final day of Solar Decathlon India 2022. Thank you so much.